ready for today. I don't know. I don't know if I'm ready for today. I think I'm ready for today. I didn't do any of the coding work that I thought I'd get to, so that's fun. And I took an Advil PM last night, so I feel like I'm still asleep. I'm gonna be clear chatty. This one, more. There. Alright, we're prime. Shouldn't be too difficult today. We should have a pretty easy time of it today. Oh, mic's weird. Got a pretty easy time of it today. I don't suspect we'll be seeing too much drama from the project here. Don't have a lot of mouse room. One thing. But we can get past this little hurdle. I think I'm really hoping we do have that $50 packet. If we don't, I'm gonna have egg on my face. I already do have egg on my face, almost constantly. It's called streaming. It's called streaming project, where you don't get to wash yourself of any criticisms. They all come out to fruition. Come out to bite ya. I have Red Bull to try to get over the Advil PM that I took last night. I took one of them Advil PMs. Helped me sleep through the night. I felt super rested for about 10 minutes this morning. And now I'm fighting off grogginess. Good old Advil PM, right? What a load of piss. Sucks. So it turns out that entire thing pulling apart the Keurig just to get the one tube. I don't really need the tube. I don't really need the tube. Don't actually need this. What's up, Dulios? How you doing? We don't actually need these. We don't need these. Again, egg on my face, right? Here, check this out. Check this out. I got these guys right here. I removed the modules from my test power supply, and I bought these $11 water blocks. What's up, Wayne Johnson? Thank you for the 25 months. I didn't see that. All good? Good to hear. Good to hear. Wayne Johnson, thank you for 25 months. Very, very nice of you, my friend. Look at this thing. So, the power supply is going to be a square board. About 120 by 120-ish. I would love to integrate the capacitors with this, because we've got all this height now over here, but I don't know if I can find the right value capacitors to go sort of, between where the circuit board's going to be and the bottom of this thing. But then I can 3D print a frame that will press the water blocks up against basically the circuit board, and I can see if I can find fasteners that I have springs for, so that it'll be pressed together by the active force of the spring. And then that will make the power supply. We'll get 750 watts out of the input module. I haven't bought it yet. I have to buy an input module and possibly one more of these, because these are probably dead. These three right here were subject of experimentation, and I think subsequently have died. So I need to buy new modules, machine off the tabs, which was a bad idea to start with. I never should have done that, but here we are. Because if I had little tabs sticking on the outside of these, I could make a bracket that holds the modules down and not presses the whole circuit board down. But again, past decisions. I never thought I'd build a square form factor kind of power supply. But in the computer, we have plenty of room for this. So I can kind of go all out and make a really cool circuit board that's going to have the 750 watt input module. For some reason with Vicor, they're like, yeah, you can make a 1,000-watt power supply. And I'm like, cool, I'm gonna make a 1,000-watt power supply. And then they're like, well, but the input module only goes to 750 watts. It goes to 1,000 if you give it 240 volts. But without 240 volts, you're stuck at 750 watts. However, the computer as it is right now, I haven't been able to put it through any hardcore paces yet. I'm sort of like reluctantly approaching putting it through hardcore usage, but it seems to be okay so far with a 750 watt power supply. Now, I probably just need to like pony up and install Cyberpunk. The worst that I have for it is Witcher 3, and that can run on 2-generation old hardware, 3 even. So it's not really that much of a test. So I will have to figure out. Ooh, my lower stomach is starting to grumble a little bit. I might have to have a couple breaks this stream. I don't know. It depends on if the Red Bull's gonna cut through me or not. Anyway, 750 watts. I think that's enough. I'm not sure though. I probably have to put a large capacitive, just like inrush handler, like just like a bunch of big caps on the 12-volt line, which I hate to do because that means that everything acts really weird. But I think it's necessary. Possibly big capacitors with big resistors on them or something. There's something to handle like something that suddenly needs a lot of current. I just don't know what the exact specs are on that inrush. I don't know what that's gonna look like. Or I build it and we see if it works. You know, it might just be one of those. It might just be one of those things you kind of like shrug and you're like, I guess it's all right. Oh, I should also mark these before I let bygones be bygones. But with that, I can water cool the power supply, which is weird and awesome. Water cool the power supply, water cool the graphics card, water cool the processor. I got 2 big radiators that I can sit on top of the computer. I've decided to make them look like a motor. Basically, 3 80mm fans make up the form factor of the computer. So, that's not a very visible X, is it? That's a little better. I'm just gonna put X's basically all over it, just in case some of them wash off or something. Just so I know that this is one of the ones that blew up, because when I disassemble the old power supply, I'm gonna have a bunch of these modules floating around, and I won't know which one's which unless I mark them. That's what I'm doing right now. This pen is not good. Hold on, let me get a good pen. Or maybe it might be the surface is not good. How y'all doing? I haven't been streaming a lot lately. I don't know, I was super duper tired. Not anymore. Well, I mean, let's be fair. I am tired today just because I took a fucking Advil PM to get proper sleep. But I got proper sleep. I'm just a little groggy. But yeah, I'm feeling a lot better than I did last week or the week before. I don't know what the hell that was about. I don't know if I like came down with something. I'm always tired. I'm an adult. Yeah, I've told a nurse that one time. Do you have any fatigue? I'm like, yeah, I'm an adult. Like, I'm a grown-up. That's like you just defined being a grown-up. But yeah, no, I was over-fatigued. I don't know what it was. By the way, this is Big John, buddy of mine. This is a mix. This is a fairly recent mix from Big John. It's from 2010. It's from 2010. That was like last year, right? That was like last year. It was like 2010 was like, yeah. This is 3 years before I built the power supply with the circuit board. But yeah, so I'm gonna upgrade it to 750 watts, and that should be enough for the new system, all things considered. We'll have to see. Half-inch ratchet and Big Daddy Ugga Dugga. You mean that breaker bar? I love my breaker bar. I've got a big old Craftsman breaker bar. Love it. I have not been able to harm it in spite of all the weird shit that I get up to. I do want to clean up some of the machining. Ugh. I don't like this song. It's the flute is kind of like a, whatever that instrument is, it's like a sour note. I'm gonna just do this. Oh god, it's still here. That's a little better. It's just a little off key. I don't know. Well, that's cool. What do you have planned for the new caveman tools? Okay. We're gonna need to do a bit of coding at the beginning of the stream. Do some coding. I'll leave this unplugged actually for now. Oh, an impact. Oh, okay. I have two electric impacts. I never thought electric impacts would be up to snuff, but they're pretty damn good now. I'm actually afraid of them, to be honest. There was a video that I saw of somebody with a similar impact wrench. All my friends, I think, have the newer, more expensive version of what I have. The newer, more expensive version of what I have, I think it's Craftsman. It has, or no, DeWalt. It's DeWalt, but it's DeWalt, and it has like a mode switch. It's got like 1 and 2 mode. And there was a video of a guy just going around a junkyard with that impact wrench, and like I think it was like a hex attachment on it, and he was just loosening bolts from like Subarus that have been rusted on for decades. He was like, oh, it's a burp, 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 and just everything was giving way to it. Modern impacts are scary. Super duper torquey. Yeah. The big one will render anything non-existent for you. It's pretty insane. So 750 watts of power coming out of this thing. We're gonna be like somewhere in the 80s or 90s in the efficiency. I don't know, I'd have to add up what the efficiency of this module is versus 3 of these modules and then come up with the percentages. It's a simple calculation, but it's annoying to do. It's annoying to find the numbers. But in any event, we're gonna have 750 watts available to this thing, and then like maybe like 10-15% that we're gonna be converting into heat. And so that 10 to 15% of 750 watts converting into heat, water blocks. I decided to not fuck with radiators, or sorry, not radiators. Blah, 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 blah. My brain is like my brain's on like neutral right now, and I'm pushing it. I've got a donkey strapped to the vehicle, and that's pulling the vehicle as we move forward. Goddamn Advil PM. I woke up feeling so good, and now I haven't actually woken up, and I don't think I'm going to actually wake up today. I'm not gonna be like on edge like I normally am. I'm gonna be half asleep. I feel like I'm in bed right now. So anyway, the that waste heat. I decided I'm not gonna mess with heat sinks. I'm not gonna mess, well, technically that's a heat sink, but I'm not gonna mess with fans. I could put a big heat sink on this and a 120 millimeter fan underneath it and cut out the floor of the computer, or I can use water because it's fucking crazy and people will lift an eyebrow at it. Now the thing is, in the water loop, I'm gonna be using all kinds of different metals. We have aluminum, I have nickel, I'm gonna have brass fittings on this thing. I don't know what to do about that, and I think maybe just using somebody's fluid, oh, that sounds wrong. Using like a non-corrosive fluid that's not as electrolytic is the only avenue that I really have. That's all I can really do. And also hope that there are not potential differences between the different parts of the computer. Hopefully everything's at the same earth-ground level and there's no electron exchange going on anything through the material. But yeah, that's gonna be the scoop. I mean, there's nothing I can do to keep it all the same metal. I literally cannot. I can't find, I mean, unless I get into plating and I plate this in nickel, and then I plate the brass fittings in nickel, and then I plate, well, okay, the EK stuff is in nickel. Yeah, there's just no way to avoid. There's no way to avoid mixed metals, and I don't know. When you get out of the realm of just traditional store-bought stuff, which is where I live, I would hate to water cool just using products that I buy off of a shelf, and everything is just cookie cutter. You know, I hate that. I don't like that. I have to get weird with it, and this is getting weird with it. We're gonna have a water-cooled power supply hooked up to the whole thing. And then in order to do the top part, I don't think it's on the camera right now. Yeah, it's not. Just at the base of this, I have just sort of my pseudo setup down here. A packet of ranch, too. No. This desk needs to be cleaned. I know. Try not to put brands. I was thinking of doing something that looks akin to an engine block. So having the two radiators at an angle with the reservoir in the middle looking like a carburetor. That's the thought, anyway. I don't know about fans up or fans down. I mean, fans down would put the fans below the reservoir, and they would be a little less striking, and then the sides would just be radiators that I would put a grill over, which would be a little bit more compact. But then again, I'm not exactly going to win any awards for compactness on this thing. I don't know. I'll give you guys a different angle on this thing, but I just don't have it. I just don't have it. No, I don't have it. I think one of the things that I need to do in the design that I'm working on right now, I've got this maker beam frame around those radiators, and I need to get rid of those. Oh, no, it's more off-key weirdness. I gotta... Nope. There we go. Hidden awards program. What are you talking about? What? Huh? What are you talking about? So yeah, 750 watt power supply in this much space, and it's water cooled. I have all kinds of cool stuff going on it. I don't know if I want to involve Nixie tubes in the computer build now, just to give it a weird sort of alt technology look. Because if I got all this space on the top piece right there, I'm basically making a giant empty cathedral that a bunch of tubes can live in. I'm definitely gonna put a flow indicator on it though, because it'll just be fun to have something spinning. Spinning. I think I do want to do fans. Well, the problem is that the processor is right beneath that right side radiator. And the processor has fittings on it, and they're right where that thing sits. I think without the frame around it, it'll sit in the right spot. Yeah, I'm gonna have to think about that and work on it a little bit. And that's basically been my weekend is fighting the CAD program. My hair is still a little bit wet. What's going on here? Hey, you wanna settle down there, hair? Maybe nobody asked. No, it's just not gonna cooperate today. But anyway, I've been struggling with CAD all weekend and trying to get my ideas into the design so I can start to build solids that I'm gonna 3D print in order to tie together the water cooling stuff on top of the computer. I decided that because I have all of this water cooling stuff, Exhibit A, I need to use it finally. I need to actually finally make a water-cooled computer. And in order to do that, that means that I have to take apart the Founders Edition card that I just got at some point. I mean, obviously, I have a ways to go before I get there. But I need to take apart the Founders Edition card carefully, very carefully, and I have the water block for it. It's that blue thing sitting at the bottom of the screen there. I put painter's tape over it so I wouldn't damage the acrylic. It sucks because the EKWB, whatever the water block company, has a really good looking version of the water block for the 6900 XT Founders Edition. It's got a really nice, it keeps that, like, some of the design elements of the 69 and 6800, but it's $250, so I'm not getting it. It's $250 and you can't even see water in there. It just kind of vaguely resembles the Founders Edition card, which is gorgeous, but yeah, so anyway, I'm not doing that. It's unfortunate. I already have to spend that much money on this power supply. But I'm excited because I think this will be a really fun project for us to do. It's fairly simple schematic. There's a lot of layout going on in this thing. We can figure out the capacitors and stuff like that. And then I have a water-cooled power supply, which is psycho. It's psycho, having a water-cooled power supply on your computer. I know there was one time that I was just kind of like fiddling with the computer, like redesign, when we did the redesign to make it, you know, look different and have a better heatsink. I know Louis popped in and was like, holy shit, he's building a power supply. And I get that a lot. I get people like, whoa, he built his own, like, he didn't just build a computer, he built a computer. It's like, no, I don't know about that. It's like popping modules together. It's not like I'm taking 120 volts in, doing all the ripple calculations and stuff like that, and figuring out exactly what I get on the outside. I'm putting together very, very capable Lego, and it's just a little bit more fundamental than plugging components into a computer. There's just a little bit more involved in that, not much. So how about Morbius bombing again? We got 2 bombs out of 1 movie instead of a Spider-Man anniversary release, which is pretty intense. I cannot believe about that. I mean, like, did I say Legos? I know it's Lego. Octoj has been incredulous, one of my moderators. Just absolutely toxic when I say the wrong one. But yeah, Morbius, it bombed again. Sony decided that, and it's to be honest, it's good to see a company that's able to suddenly cater to a sudden meme, but I don't think they were informed enough about it. You know, because there have been resurgence in popularity for things before, right? Like, that's happened, where something that's campy suddenly gets a very large following. Morbius was not really that. Morbius was a bad movie. I don't know how many people actually saw it, but it was like, it's like this unique kind of Sony bad that I don't like. When Sony makes a bad movie, it's just intolerable, right? Like, I love bad movies. I love Schadenfreude. I love, you know, watching something that somebody tried and failed at and laughing at it. Sometimes you're laughing with the director, sometimes you're laughing at them, and it's a fine line to draw. But it's something else when you get a bad Sony movie because it's so blatant. You know, every product that any character ever interacts with is a Sony product. The Sony music catalog is blatantly shoehorned into every single facet of the movie. Like, you know, the completely out of place shirtless dance scene to whatever that Have Sex song is. Have sex. Boom, 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 boom. Sony music catalog advertisement. That's all it is. It's absolutely wild. I'll never understand how big companies can be so out of touch with reality. Like, does nobody normal work there? No, they don't. Yeah, normal people do not work there. It's executives. Executives are not in touch at all. I think it's hard for people to realize that, like, their life is not like our lives. It's that blatant. It's that simple. Now, not Morbin, talking about how dead Morbius is dead. Like, it's dead. The meme's dead. Everything about it is dead. It's bombed twice in the theaters, and I think that's insane. It's nice to see that Sony was able to suddenly, like, pump it back into theaters, right? That would have worked in any other scenario except for watching Morbius, which wasn't a good movie. It's Sony bad, and I can't stand that. I can't stand the Sony bad. There have been examples, and I can't come up with them off of the top of my head, of a movie that sort of, you know, like movies develop a cult following, and sometimes they do it very quickly after being out of theaters when the movie bombs. And so it would be a decent financial decision to go ahead and re-release it in theaters suddenly and quickly, you know, while the memes are popping off. But this is not the movie for that. It was not the movie for that. It's just not a good movie. It's just not a good movie. It's not, and like I said, like I love bad movies. I love bad movies, but there's a certain Schadenfreude that you get when it's not a multinational corporation. Every now and then there is an expensive bad movie that's worth watching for it being bad, but that's a rarer example in my opinion. Hey, Cosmo Quest X, thank you for rating with a party of 18. We're just kicking it off over here. I'm gonna be doing a little bit of programming, a little bit of programming. I'm gonna be doing a little bit of reverse engineering. We're looking for a specific signal. What's up, Keeper of Maps? Keeper of Maps, advocate of rating my stream. Thank you, thank you, thank you. Appreciate you guys. You guys are great. So I was just talking about Morbin and how Morbius failed in the theaters twice. Twice! And I don't think it's all that uninformed of Sony to re-release the movie. I don't think it's that uninformed. I think they just didn't realize that their movie's actually bad. But some people just don't, I don't want to say they don't have taste, but you know, maybe a lot of people actually liked the movie and you just didn't see it because you're just one person with one person's perspective. And you don't see, you know, maybe some people just want to like go hang out in an air-conditioned theater with something going on. And it doesn't matter what it is. Some people have different tastes. But at the same time, I mean, Sony bad is hard to tolerate. For me, at least. My kid's been keeping me informed on that because he saw the movie the first time it came out and it was terrible. Yeah, I've seen it. I've seen it. I'm not going to divulge how. But it's not good. It's really not good. It's not good. It's just not. I don't think it's fun to watch. I mean, maybe in a big crowd of people who are yelling at the screen and stuff, but it's bombed in the theaters twice now. So I don't know. It's not exactly The Room, you know? You don't get a theater full of people throwing sporks at the screen. It doesn't come from a genuine place, I think, is where really the difference there. There's no love in the movie. It's just a big commercial. Michael Bay movies, yeah, those sort of straddle the line. I think maybe they're just so ridiculous sometimes that you can watch it just for like, you can get something out of it, but not really. You're pretty right about that. Yeah. What was it like? It's, oh god, something for bats and fatal for humans. I don't know. It's just so bad. It was such a weird movie, and it was badly constructed and written and stuff like that. I've also been talking about the computer water cooling project, which is up front in the shot there. There's a little garbage on the Burn the Subs desk today, but I got the radiator. Sorry, I got the reservoir. It's a fairly new thing from EK, but it's the reason I bought it is it's little 80 millimeter box. Well, 80 by 120 millimeter box, and it looks a lot like a carburetor, if you ask me. So I'm going to use it and have the two radiators at an angle in order to cater for the tall little thing, because there's a big pump behind it. And that will look a little bit automotive, but I'm hoping to have a lot of tubes running around the thing to make it look a little bit more automotive as a computer cooling system. So the whole top is going to be the computer cooling system. On the bottom, you can go get the thing. On the bottom, I'm going to have my 750 watt power supply This is stuff that I talked about without CosmoQuest here, so I'll talk about it again. Oh boy. Oh, that was a bad grip. That was a bad grip. It was a glurp. Okay. So, on the bottom, or sorry, in front of the motherboard, I'm gonna have these guys. This is gonna be the bottom part of the computer, and I don't know what the orientation of these. There's gonna be one more of these included with it. These are size guides that I have for the modules, and I call them size guides because I blew them up during the initial building phase of the 500 watt power supply. The 500 watt power supply is 3 of these modules, right? These 3 modules. One is an input module, auto ranging. It takes 100 and something, less than 100, but from 100 to 300 volts or something. This can power 240. This can power 120. It gets 120 because I'm in North America, but 120 volts to 300 volts DC. These are 300 volts DC to 12 volts. Each of these are 25 watts, or 25 amps or something, 250 watts, 250 watts, 250 watts. And then I will have a third, which is another 250 watts, 750 watt power supply. And I'm violating all kinds of little regulations by having my high current DC crossing my high voltage DC. And then also I'll get yelled at by all the hardcore electrical engineering types saying, that's not high voltage. It's not high voltage. It's 300 volts DC. I'm gonna call it high voltage. Cheers. So anyway, 120 volts comes in here, 300 volts to these 2, well 3, and then lots and lots of 12 volts coming out on the other end in 120 by a little less than 120 by like 1 inch. That's 120 millimeter, 120 millimeter, like a little less than an inch. And I'm gonna water cool it. Just 2 blocks in parallel, 6 feet apart in a hot tub. No, two blocks running in parallel with a bunch of coolant fluids running through them. It should keep things pretty nice and cool. I'm a little concerned about the added load of the power supply on the whole system. It might mean that the processor and the graphics card don't get as cool at idle. And then when in use, this will stay a lot cooler, but it'll also be dumping a lot of heat into the rest of the system. So who knows if I'm up to spec with everything, but it'll look like a little motor, which is cool. The whole computer, that is. A lot of work between now and then. There's a lot of work between now and then. We got to do a lot of. I have like beehive hair today, huh? Yeah, we got a lot of work between now and then. There's a significant amount of circuit board design. There's a bit of vetting that we need to do. I need to make some decisions ahead of time whether or not I need extra capacitors on like everything in order to be able to inrush, because that might be what was killing the 500 watt module, is just a sudden inrush of current that maybe the 750 watt power supply can't even handle. So anyway, this is just before stream. I don't know why I need to explain this individually to every single person. I could have one of these up and then it would really be like a normal stream starting soon. But OBS is one piece of software. When people have the starting soon thing up, they're there. They're just sitting around, or maybe turning stuff on, or maybe like arranging stuff on the computer. I don't know. I gotta get a haircut, and I need to cut the beard down. I think it's about time. I'm a little too hobo. The glasses have become a suddenly necessary thing in order to keep hair from whipping into my eyes, which is bad. That means things have gotten a little out of hand. I don't know when I'm gonna do that. Maybe tonight I can call and see if I can schedule something for Wednesday. All right, we should probably get started. It's a quiet Tuesday. Usually on Tuesdays we kind of go out of our normal purview, and I start something and I figure out that I need to order a ton of parts, and then they get here hopefully by Thursday, but usually not. But I think today we have a very clear idea of what's going on, so I'll get into explaining that right now, and then we'll roll from there. But I'm not going to be too crazy about today. I'm not going to, push myself too hard. And then we get rid of that. And I'm also not going to explain myself to every single person that comes into the stream, because we get that here. People come in and they want to know what's going on, and that's fair, but it's like I can't explain this in an extremely succinct manner because there's a lot of complexity about the projects that we work on. We sort of take an organic approach and sort of phase into new stuff as we keep going. So that's sort of where we are with a lot of the projects right now. We kind of have new stuff that we need to look at, and it's like fractal. It's like a fractal project. The more you zoom in on a part, the more complicated it gets, and it continues to do so ad infinitum. What we're looking at right here is the purchase page of a wireless button plate module. It's part of my simulator setup that I built using actual car parts and a Granite Devices SimuCube. The cool thing about Granite Devices is they make these motor controls, these 3-phase motor controllers that are universal. And so you can just buy a motor off of eBay, slap an encoder on it, if you're capable of doing so, and turn it into an industrial servo like it was originally meant to be. Usually things are closed off within a manufacturer, like Mitsubishi is sort of closed off to a Mitsubishi controller, whereas Granite Devices, you can take that Mitsubishi motor and characterize it, figure out some of the parameters of it, plug it into the module, and then the module can use it. What we're using it as is as a direct drive steering wheel. This is sort of a spin-off of the Open Wheel project that Granite Devices, a Finnish controls company, took under their wing and decided to make a circuit board to help you build your simulator setup. And so we've been running that for a while. What I did was I found out the protocol that the steering wheel uses. I bought a Mercedes, an actual Mercedes S-Class steering wheel, because it's comfortable and it's leather and it's an actual car part, and it's pretty cool. And it's got shifty little buttony paddles on it, as well as buttons on the front that you can barely see right now. Little buttons on the front of that thing. This thing has 3 wires that come out of it. 12 volts ground and what's called LIN bus. So we reverse engineered the LIN bus protocol coming out of the wheel, and we were able to brute force the address of the Mercedes steering wheel. Don't mind the BMW airbag cover that I just shoved in that. I just needed something to cover the hole. So we figured out how to get all the button presses out of the wheel. I added a gated shifter. That's part of the upgrades that we're going through right now. I added a gated shifter, which added 8 individual buttons for all the shifting locations. We did a little tweaking and tuning to 3D parts on that one. Then we also have a set of actual BMW pedals that's on a thing that I can clip to my office chair to make it feel more like a car. So all of those things together are actually all speaking the LIN bus protocol. We made our own LIN bus accessories out of these 2 things, and we were able to get values out of them perfectly fine in a timely and speedy manner. However, the Granite Devices SimuCube controller only has so many inputs to the thing. This thing acts as a joystick in your computer, and it has a bunch of buttons. There are 4 Ethernet connectors that are actually down there. There's those guys that are not actually Ethernet connectors. They are analog button inputs. Well, I guess digital button inputs, but they're not serial. Each button has an individual pin, and there's only 8 per connector there, and you need to have a ground, and some of them have other special features. So we only have so many buttons that we can represent inside of the actual device itself. That led to the need to digitally influence the microcontroller. See, I've got 2 digital potentiometers here and a port expander that then pushes the buttons, and we only have like 16 or something like that. We got way more than that on this system, and I need to unlock all of them. So that led to looking at how we can directly communicate with this board digitally, serially. Well, the problem is there's no API. They don't have any kind of an API published. Granite Devices is like, this is whatever, who cares? They said at one point, I guess in stream, there was an employee, a supposed or purported employee of Granite Devices in the chat saying that, yeah, we're going to publish an API. That was 2 years ago, 4 years ago. So I don't think that's going to happen. But there is a system to get more buttons. Instead of doing complicated stuff like LIN bus and a slip ring, which is what we had to build for this project, instead of doing that, what Granite Devices decided to do was put a battery in the wheel. So you put a battery in your wheel, you install a little Bluetooth dongle that looks a lot like this thing, and then that Bluetooth dongle communicates with a base, the base station, digitally through a serial connection, and it gives you 28 additional buttons, and you can stack modules. So you can have 40 billion buttons on this thing. All for the price of $100 for both of these two. It's $100 fucking for both of these things. I think the price went down a little bit because I bought the new module for like 50. I ponied up and I bought this thing. But I'm not about to have a bunch of rechargeable devices on my sim setup because this thing will sit for like a couple years on a shelf and then I'll be like, oh yeah, the sim setup, let me pull that out. I want to play some games. So it's not going to get used all that often, which is why I'm not building a full sim pit, you know? Computers are like impossible to find. Man, I'm hemorrhaging viewers now. Anyway, computers are not all that easy to build, so I'm not going to build another gaming computer and then build a sim setup around it. Instead, this stuff all clips to the side of my desk, or clips to the front of my desk, and then I can use my normal desk as a simulator setup. So I don't want to have a bunch of rechargeable devices associated with all this stuff. I'm liable to have a battery explode on me. So what I've decided to do is reverse engineer the protocol from the wireless wheel module, and we are 99% there. We've gotten to the point where we know exactly how to respond to all the signals coming out of this guy in order to make this thing think that one of these is plugged in and it's connecting to one of these. In fact, we've gotten so far that we're able to spoof the Bluetooth ID of this thing in order to make it think that it's getting connected. Except that we've gotten all the way to the finish line and there's one more step and we don't know what to do. But bother, you have all the hardware right in front of you. Can't you just test it? Yeah, I got to the point where when we just started to understand, what's up, Mahalo? We got to the point where we just started to understand what was going on with these signals and we were able to spoof and make the signals and fool everybody. And then I decided to test the RSSI. And in order to test the RSSI, I decided that I should plug in to the wireless module and move it away, get it out of the room, get it into an adjacent room, and see that RSSI tick down from 100 so that I could print it out on our serial monitoring spoofer guy. So I went to hook it up to a little battery, and when I connected it to the battery, I accidentally connected it to the 2S part of the battery and not the 1S part of the battery. 2S and 1S, 2-cell, 1-cell. Lithium-ion batteries are typically somewhere around 4 point something volts, 3 point upper 3s, 4s in volts. If you double it up, you get 8 volts. And this thing can function at 5 volts, but it sure as hell does not like 8. And when it got 8, it made a little noise, and then it just stopped working. We had enough information at that point that we could almost fully reverse engineer this thing. However, we get all the way to the point where the two modules look like what we observed when this thing was functioning normally. Looks just like it, right? But it's not responding to our button press packets. We tell it to press a button, it ignores us. There's one more little communication that's going on that we don't know about. That's what we got to do. We got to learn how to do that today. That's why I spent another $51.70. And I've got a new wireless wheel module. Now we could have been done. I could have just used the wireless stuff if I didn't blow that up. If I didn't blow that up, we could have just used all wireless and I could have just had to recharge everything, right? The other problem with using the wireless wheel module with the Mercedes wheel is that these buttons are multiplexed in a very strange way. So I mean, maybe I could put a battery in here and then have a 4 to 12 volt converter that would then power the wheel system, and we'd have a microcontroller that would speak LIN bus that would then hit a port expander or two in order to hit buttons on that thing. That would be a little ridiculous though, you know? It's a little crazy. I mean, it's just as ridiculous as the rest of this project, but I don't know. I don't want to recharge my wheel. I don't know if you guys understand me. I don't know. I don't need to be understood. I'm a weirdo. It's just like, I don't want to recharge my wheels. Coil wireless. You were here for all that when everybody was suggesting ways for me to get like their super brainlet ideas for how to get signals in and out of the wheel. Just use multiple coils. Why don't you just use RF to, it's like, dude, no. Like, be realistic. This can go way to the side. All right. God, I took Advil PM last night, so I'm like groggy today. God. So Trey Pop. How do I download RAM? You just download it, man. You just download it. Just do it. Why would you ask me this question? All right, so here is the expensive module. Bada bing. Here we go. Now all this is a what's called a Blue Gecko wireless module and a port expander. So what they've done is they've taken the Blue Gecko wireless module, which is it's a Bluetooth low energy module. It's fairly capable for what it is. We looked up all the protocol and the API on that thing. It's all known. So we know exactly how to communicate with the Blue Gecko module. What we don't know is the custom stuff that Granite Devices did in order to get button presses, RSSI, and battery level in and out. We figured that out. We figured out most of that. There's one more signal that we don't know, which is the go-ahead for button presses to the other Blue Gecko modules. So we got Blue Gecko module here, Blue Gecko module here. This one has a bunch of custom code in it in order to run a port expander. That's why there's 24 inputs to this thing. I'll go to the port expander. This thing communicates with the port expander. I overvolted this thing, and this one blew up. So let's get this new one up and ready to go. And I guess we'll swap out the perf board or just move over on the perf board so that it's no longer the... What? You guys are wondering how the results of an overvoltage event. Where are we? Pretty bad. It's pretty bad news over here. Let's go to the other side of the perf board. That's a... I didn't stick a soldering iron in that. You can see by how fucked up that one pin is what happened here. So we're just going to transfer all the stuff over to another module. Let's see if we can zoom out a little bit here. Can that focus? Nope. All right, that's about as far as we can get away without me doing weird stuff with the camera. All right. Man, it's pretty warm down here today. I don't know if I'm going to be able to tolerate it. Oh, you know what it is? The fan. Hold on, I gotta move the fan. I gotta move the fan so that it's actually blowing on me. And I would like to move in a little bit here, but the wheel gets in the way of everything. Whenever we have the wheel out, it always takes up most of my desk. They don't necessarily need to have the wheel plugged in for this thing to function. We've had it plugged in just to show that the buttons work and everything, but I don't know if this thing, oh no, it doesn't, this doesn't display button presses unless the wheel is detected and everything. So yeah, so that stands to reason that we need the wheel here. Ugh. Okay, all right. So this module, this is the receiver. We can just plug that in right now. There are two headers that have the right output pins. So we have the TX and the RX just coming through this cable is just there so that I can work over here instead of having to saddle up. Now let's see, we got power coming from here, but I think I want these wires to be behind everything so I can actually get to stuff. Yeah, that's better. That's a little better. Yeah, I can actually have room to work. This is USB from the computer. This is USB to the computer. I mean, from and to, it doesn't, they're both bidirectional. Whatever. All right, get all that stuff stowed away. And then I need pins. Pin is mightier than the sword. Where's my pins? There are my pins. Okay, pins. A couple different methods for doing this. I think I'm just going to solder again, but you could wire wrap. Wire wrap is always a good way to do this. You can. The only problem is the length of the post that you're wire wrapping to, because the ends of these guys aren't very good for that. It's this end that would be better for it. So you could solder a header to a header and then wire wrap on the outside of the header, and then your wires have a little bit more strain relief, especially if you're using these wire wrapping wires that I'm using. They don't have a lot of strain relief like this when you just solder it directly. But I don't know, maybe I overemphasize strain relief in my project. It's kind of an important thing. I mean, these solid core wires, they break very easily. So we're just basically going to put the new module in like we had the old one. Ugh. All right. So yeah, I'll just move connections over to the new one, and then I might need to solder some headers on this just so I can place the module down on the... Is that the same? Yeah, it's the same layout. Okay, all right, just making sure. This should be the same board, although it looks like Murray Motorsports has sold a couple of these between the times that I'm ordering them, huh? that or they just, you know, grabbed a different one out of the bin. But I wonder if that's a serial number. Like a GX on the bottom of it for some reason. The only place that I could find that sells just the board is Murray Motorsports, which looks like a good company. I haven't had a lot of experience with them at all, but they seem pretty good. Granted, Devices will not sell these individually, and they don't want other retailers to be selling them individually. So we're lucky. We are lucky. I don't know if I want to vise it. I'll just put it on top of this to solder. All right, and then we don't need this Gigantmo soldering tip, right? I had this on here because I was removing power supplies from my sort of size guide for the old power supply project. So we just need like a normal tip. I haven't used this one in a while. Yeah, changeable tips are like key. They're super nice to have on these. Why is it all washed out? Is this a camera being weird? No. That's just the circuit board looking weird. Okay, so get this down here. This is just like a random generic heatsink that I use as a little pad for some soldering stuff. There's like a lot of wires and stuff in the way today. So, I mean, I basically want the exact same thing out of the new module. Oh yeah, one thing that we want to do is put the LED on this too. So one thing that they don't install is over here. It's an LED. Where is that? Yeah, this guy right here. We want here. I think that's it. Yeah, we just need the LED over there. The pink LED that we soldered in. Let's actually put this thing in the vise then if I'm going to be doing that. And I'm going to move our view over here so I can work a little bit more comfortably. I'm sort of pushed over to the side on the desk today. So I'll try to move it over here so I can actually comfortably work. We're just going to take the pink one out of the old one and put it in the new one. Just a quick little transfer. So once we set this thing up with all the wires on it, we'll be able to access the shoulder buttons and then give it power, and that will allow us to get it registered as a device. There's where it goes. There's where it comes from. Cotton Eye Joe. That heat up. Now, any solder that I add to this thing is going to be way too much. But I think maybe I need to refresh the pins a little bit. So I'm going to do that. Everything's very, very small on this board. I feel like we're like way out of focus too. That's a little better. Any minor touch to the desk is going to cause you guys to shake around. All right, so here's this connection. Yeah, you guys are real shaky today. That's what happens when the camera's properly calibrated. It's very sensitive to motion. So I gotta like move my legs so that it's not resting against the table here. All right, well, too much solder, but that's okay. We can remove it. We can remove it. Can and will. Yes. All right, give me all that. I'm hoping we can make a lot of progress today because it's so frustrating that I had to do this. I had to buy another one of these modules because we really were 99% of the way there. All we had to do was get the button press to activate. And I have a feeling, and this is just an assumption on my part, is that there is some kind of last serial signal, and we didn't capture all the way out until that last serial signal. What direction does this thing face? How can I tell? think maybe I just need to, I'll get a new LED. We'll find my LEDs and get a new one. But I can test the direction with a multimeter if I put it in diode mode. Diode mode. Let's go to diode mode. Diode mode. And we can see which direction this thing lights up. Ground there, power here, negatron. Move it around. Oh, my leads are getting all tangled. So, power here, up chop, ground at the bottom. What? What? Huh? Huh? Am I not making good connection? Hold on. Kind of dig it in a little bit. No? Okay. Flip it again. Why not? Sometimes you got to break through like an oxidized layer on these. There it is. It's not giving me a voltage, but that is very pink. So positive is on the left. Anode is on the left. Anode on the left. Anode on the left. I guess the cathode gets the dot or something. The band is on the cathode. Yeah. Yeah, that makes sense. That makes sense. Multimeter back over there. I gotta find an LED. Let's go to this view. I gotta find an LED. So I gotta go through some of my bins over here. Hopefully my audio doesn't get too scuffed from me looking down and talking at the same time. So where did I put those LEDs? I got some fancy new LEDs I can use. Fancy. Nicey nice. That's not it. There's some of them. Okay. Capacitors, no. Nope. Don't even know. No. A lot of connectors in that one. They're there. So I've got pink. I like amber. You're boring. Pink, ultraviolet, white, orange, green, yellow, blue, red. I'm gonna use pink again. Boop. So on these, the little T shape, the flat part of the T shape goes to positive, which is counterintuitive as per the symbol that represents an LED. We got this little guy right here. We'll just go pink again, just because we can. It's we don't really need much from the LED, to be honest. It's just an indicator of module status and stuff like that. But I mean, we're gonna want it. It's just this is like a temporary setup. This is only gonna be for, you know, like an afternoon. We're gonna have this thing configured. So this LED is far too large for the socket that it goes in. I could probably hunt around in the scraps and see if I can find like a smaller LED, but we'll be able to get this to fit on the pads. So that band right there marks the anode on this thing, and the anode goes to the left because the symbol for an LED is an arrow pointing to a flat bar, and the arrow is pointing from positive to negative. It's like that. That's the ticket right there. So the way we do surface mount chips is we solder one pad, we put solder on one pad, and then we slide the component into that pad. Grab my, oh wait, we're not on the multi-view. Well, you know what, we don't get the multi-view right now because I can't reach the control. I don't have three hands, you know? So this is unfortunately a bit oversized. We can still deal with it though. And just get solder to flow a little bit onto that pad, and then I'll clean it up in a minute. Now this is still my old solder. I bought some new solder and it's a smaller wire, which means I can put it into this stuff a little with more control. Unfortunately, I don't have that control right now. So this is just going to be a sudden influx. Yeah. I hate having to drag a bead of solder over to something. That's a very sloppy way to do things. That didn't solder at all. Like, yeah, you can use flux to help you with stuff like that, but it's not really, really necessary here. I mean, this is rosin core anyway, so when I add solder, I'm actually adding flux as well. The fan inside of the backup power supply for the rack mount is making a little like ticking noise, like, and so that's all I can hear right now, in spite of there being a floor fan going at the same time. All right, so now we have an indicator LED. It's not the best soldering job, but we know that it's making a connection, so that's all good. I think the bottom part's making a connection. We can get closer if we need to. Earthquake! So we're dealing with a little bit of parallax here. We can just kind of like either move this around or pick it up. I mean, that metal goes all the way around the chip, and it should connect, but I'm not too confident in it. So I'm going to try again and just maybe add solder. You guys got to realize how small this stuff is. I mean, I don't want to overdo it with the solder, and I just did. At least this thing allows me to pick away some of the excess. I just want it to kind of like flow around everything so that I know that there's a connection to that. It can be sloppy. It doesn't need to be a clean connection. We're not even going to use this board when all is said and done. There. I'm a little happier with that, even though it's still sloppy as hell. It's just an LED, right? All right. That should light up when we get everything else powered. Let's transfer over some of the lines here from one to the other. Okay, and then we get, yeah, we just transfer stuff over. So just pick this up. Well, actually, I'm going to resolder the connector, but for now we'll just we'll leave this connector on there, but I need to redo it because it's not good. Actually, we can move it up too. We could move it up to here, and I could just use a straight header. Probably do that. Here, let's get this out of here. Get all this out of here because we're going to redo a lot of it. And I'll just transfer the wires over, and then I'll cut the connector off. I just don't want to. I don't want to look at the data sheet or anything. I don't want to remember what I'm connecting where. I just want to transfer it over brainlessly. So we need 1, 2, and then 3. Okay, so we need this one, and then the row below it, the one in front. Okay, 1, 2, 3, and then over here, the 2 that are next to each other on the bottom for power. All right. Just starting to learn some electrical engineering as a hobby. Tiny surface mount stuff like that intimidates me. I find it easier than through-hole. But yeah, when you're just starting out, you know, all the big stuff is the way to go. The 0805 size is really for me, that's like a sweet spot of like electronic size. 0805 is really good because you can use perforated prototyping board, which is this stuff. Yeah, I have it like in reach. You can use perforated prototyping board, and an 0805 like chip resistor will go between the pads on these things. And the ones that I really like for building little, you know, like if you have a semi-permanent semi-test circuit that you're building, use the, where'd it go? Single-sided square pad perforated prototyping board. And the square pads just give you a better interface for something like a chip resistor to solder onto. And then I use 30 gauge wire wrap wires, which are what these things are, in order to do all the other connections on a perforated prototyping board, and that way I can drop the wires down below the board where there's no pads or anything and route them around. So it's kind of similar to wire wrapping, but not really. That's the technique that I use. Obviously, I mean, through your exploration of the realm of hobby electronics, you may come up with your own techniques. But mine come from like people at government agencies who sort of really know what they're doing. So stolen a lot of techniques in my day. I can't even see this wire. I'm gonna do this. I'm too far away and my eyes are like not focused from, of course, taking fucking Advil PM. I'm tired, even though I'm not. It just means that my eyes just don't want to work right. So yeah, let's just do this. This way, at least I'll be able to see closely what I'm doing. By the way, when I stream, I am viewing this in the same exact way that you guys are. So I am looking up at a monitor that has all of these panels on it and seeing directly what you're seeing. So if you have trouble with parallax, I have trouble with parallax. Parallax being perspective is what I'm trying to say. Perspective can really mess with you when you're doing stuff like this. Like a pin header will look like it's plugged into a row above where it actually is. Because we don't have stereoscopic vision. I worked with those, what is it, Scorpion magnifiers, and they're cool as frig. They have a lenticular mirror inside of them that spins, and it gives you a three-dimensional, it's like that, it's not Buck Rogers, is it? Anyway, it's like that arcade game where you get the 3D view and all the QuickTime events, but you just basically look into the viewport, and it gives you a three-dimensional view of the microscope area. And the problem is they would zoom in so far, and you wouldn't know where your frickin' soldering iron was. You had no awareness of that. So you'd end up waving your soldering iron to try to see it, and then end up poking yourself in the finger with a hot soldering iron. They were great, though. They were really fun to use. All right, and these two. So power is towards me. I have the power. It's towards me. Let's do ground first, because it's easier. Solder this. Oh, this is really awkward. Hold on. This is really awkward. So yeah, we get a lot of people coming in here who are just starting out with electronics. It's hard for me to recommend stuff because I'm not starting out in electronics, you know? I've got like 10,000 years of being in this hobby that has informed me. Why is this not doing anything? What's going on here? Are we not in saver mode? Why is this not soldering? Is it just done with my shit? I think the tip's so dirty that it's not soldering. Yeah, let's clean the tip. Let's add a little bit of solder to this pad. Hard to see. Sorry, everything's moving around a lot because we're doing a transfer from one device to the other, from the device I exploded to the other. But yeah, I've not been starting out in this in any reasonable time. If it were 1999, I could tell you what books to buy, but it's not. So we're in a different era of all this stuff, and okay, power is towards me. I want to get this thing out of here. We're in a different era of this stuff, and it's easier to start out and learn a lot of the fundamental core things that you're going to need without a lot of the garbage. Back in my day, as I adjust my cane, my walker, back in my day, the books would be like, hey, welcome to electronics. For our first project, we're going to plug a transformer into the wall without a fuse and make 12 volts AC. Do you like coiling wire around a ferrous core, little Timmy? Plug it into the wall. And then have a cigarette. Like, it's ridiculous. Yeah, I blew up the other one. This thing is only stable for a certain number of volts, and batteries come in 1-cell and 2-cell flavor. And so I accidentally plugged it into the 2S connection for the battery, and I gave it 8 volts, and it does not like 8 volts. It has reverse connection protection. I was trying to think of stuff that rhymed with that and kept going with the rhyme, but I messed it up because I didn't think of anything. But yeah, it has reverse connection protection, but it doesn't have, overvolt protection. So I'm SOL. I'm just gonna metal fatigue these off. Metal fatigue, metal fatigue, metal fatigue, metal fatigue, metal fatigue, metal fatigue, metal fatigue. They're solid core wires, so you just bend them a couple times and they explode. Yeah, but I hooked up too many volts to the other one and it popped. We took the cover off of it to try to unpop it, but that wasn't happening. It wasn't having any of that. So this is a dead device. The blue gecko module has exploded. But what I was saying earlier is that, okay, that just knocked a bunch of stuff off of my desk. I wonder what. I guess I'll never know. There was probably important stuff that I put aside over there. I just tossed it into this little area right here, and I heard a bunch of stuff hit the floor. Hit the floor, Jack. Don't you come back no more. Okay, yeah, God, blowing stuff up like that sucks. But anyway, so what I'm saying is that, like, back in my day, in the early 90s, when I was first starting out, they would jump right into, like, the most dangerous project that you could possibly do. That's not the world we live in today. We have a wonderful and actually just comprehensive, what do you call it? Structure, everything has tutorials, everything has beginner stuff, everything, like, it's all just Googling away. And it's all like 5-volt digital, like with the Arduino. Very easy stuff to get started with. And if you're more into programming than you are into the electronics, but you still want to get into the electronics, you can do that. You can buy a basics kit and just plug away at some of the basic tutorials that they have and get a sense of what's going on and how things work. I used to have to learn a lot of analog electronics in order to get there. In order to get there, I really would like to find a pin that has enough room. Well, I guess we're just plugging it in on the one side and soldering it on the other. So I just need 5. 1, 2, 3, 4, 5 breakaway headers. Bada bing. There we go. Yeah, you guys can go pretty far with that stuff. If I was 10 years younger, well, if I was 10 years, I was doing this stuff 10 years ago. So, but yeah, if only, you know. So many good jump off points. Oh wait, I need 2 more. I need 2 more. I put it away in this. Damn it! When this thing is full, it's hard to get these things out of here. Little sewing box things. Okay, that I actually managed to do that. Bada bing, bada bang, bada boom. About this time in the stream is when somebody would wander in. Like, we get like Turts or like ADHD degenerate wandering in, and then I'd be able to say hi to them for a minute. Right on cue? Nope. Okay, didn't call it. Never mind. Yeah, one thing that we suggest here, one of the methods for learning how to do stuff here, is find something that you want to do. What do you want? You want to improve something in your life? You want to build something that looks cool? Do you want to go for a walk? Walkies? No, do you want to improve something in your life, or do you want to build something that looks cool, or do you want to cosplay with and have LEDs and cool stuff like that? It's like, figure that out. What do you want to do? And then try to break it up into individual projects. What can you learn on this step of the project? What can you learn about this step of the project? What tutorials exist that teach you the individual pieces of that thing, and then put them all together. So a lot of projects, a lot of the more interesting projects out there spawn from a bunch of other projects. And you just end up putting a big system together out of all these little systems. You know, I want to learn how to blink an LED because eventually I want to make a Halloween mask with eyes that blink. And that way, you have a goal and a bit of motivation to pull you along. Because motivation isn't always going to be in supply. Oh, crap, I didn't break in the holes on this thing. Hold on. This is not something that I'm typically used to having to do, but apparently it's something that has to be done with these things. I have a set of clay working picks. They're actually kind of dental tools, to be honest. But clay working picks that are made out of cheesium. They're not good. They're very weak. They're very destructible, but they were cheap as a result. So what I do is I take this and I stab my gums, and then I go, why am I bleeding? Just like when I go to the dentist. No, what I do is I take this and I stab all the individual holes, and that kind of breaks them in a little bit, because these are, for some reason, they're like destructive of electronics when you start out with them. They grip too hard, and they end up destroying stuff. So I got to take a minute here and just go over basically all the holes in this thing, and just make sure that they're usable. Maybe I'll stick to the top route. I don't think that's going to work. I just need to get through this. So just give me a sec here, chat. Give me a second. Should go relatively quick. At the expense of my wrist becoming a claw. Entropic Heaven. Hey, thank you for the 8 months. I really appreciate those primes. Listen, guys. Twitch Prime. Did I mention about Twitch Prime? Twitch Prime is not a new program from Amazon, as evidenced by the number of months. But it does not remind you when you should re-up your sub. All you can do is just say, hey, where did my emotes go? And then you got to wait like a little longer for it to suddenly show up and tell you that you can sub. So those of you guys out there, Tech Life More, thank you for the $1. $1 and a little pulsating, weird, creepy heart. Those Prime subs, they don't tell you that they're up. So the people who have multi-months with like streaks and stuff on their Prime subs, hey, that's awesome. That's humbling to me. That means that people are paying attention, which is not, not something I expect. All right, give my hand a second here. Oh, muscles, come on, come back to me. You can see the vein structure, and oh wait, no, I just squished it, so you can't. You can see the vein structure in my arm by the thermal imaging. Look at where all those veins are, man. This is what all the doctors have been looking for all this time. They keep missing. I got like deep veins. I don't know what it is. I got deep veins, and for some reason I'm never hydrated. I've found that on the days that I have to get like blood stuff done, I need to drink, like the night before, I need to drink like 2.5 liters of water in order to get, sometimes 4 actually, in order to get myself bloated enough on water that they can actually like do stuff. They can actually get stuff out of me. I was just breaking this in. Sorry, got to do this. Sometimes you got to do this on stream and it's embarrassing. But we've got a relatively simple task ahead of us, so I'm actually happy to have more people gather for this because this will be interesting today. What we're going to do is we're going to take our old code, move it over to a new sketch. In Arduino, the different programs are called sketches. It's a sketch gets uploaded via the bootloader to the microcontroller, and then the microcontroller uses the bootloader to put that memory into the right part and then start executing the code that you've written. So that's the beauty of a bootloader, is that you only need a TX and an RX, so you can use a USB hookup in order to program it instead of the big comprehensive JTAG connection or whatever connection you're supposed to use in order to pump code into your microcontroller. You can make a bootloader and a simple TX and RX, and it's a lot cheaper. So you can have these cheaper microcontroller platforms that anybody can program from any computer. That's the beauty of Arduino. That's what those Italians made up at some bar in Italy called Arduino. Arduino is a bar. Anyway, they came up with that system. We had, like, at the time, we had like the basic stamp and like the PIC microcontroller. And PIC you would do in, I believe, machine language. You could do C. We had AVR stuff, and AVR Geeks was the website for that. I could never break the surface of microcontrollers. I was like, man, these things are super cool. I could do some cool stuff with them. I just don't know how to kind of like break the ice and figure out how to program these things. Because you would think about it in terms of like simple code. You're like, I want this pin to do that, and I want that pin to do that. right? That's how I would think about it. That's how I'd approach the problems. But that's not how you would program them. You would be moving data around and putting banks into some banks and stuff like that. And then in order to start programming the microcontroller, you would first need a $300 programmer. Then you would need to figure out all of the specifications of the microcontroller, including clock speeds, like setup flags that would make different fuse bits. They would make different functions active or inactive on the microcontroller. And if you get it wrong, it bricks and you can't do anything with it. So it was a weird and scary world to get into back then. And then the Arduino kind of hit the scene, and you had a $20 microcontroller that you could plug into a computer, and you would get a very simple interface, and then you could just start writing code, and you could say digital write pin 5 high, and it would go high, and then you'd wait, and you'd say digital write pin 6 low, and it would go low. And so that simplicity brought microcontrollers out to a wider world of creative endeavors. And you saw suddenly everybody migrate to the platform. And so now it is a de facto universal kind of thing that where, like, if I can literally go into some of my electronics bins and pull out a display from the 70s, plug it into a perforated prototyping board, and look up the Arduino code for it. Like, and we've done that. We've done that here. Yeah, you don't even need, I mean, they have it, multi-core, but you don't need multi-core for most projects. See, now that just plugged in, just totally drama-free, right? Just plugged right in. And so you saw before I tried to press it down and it was kind of fighting me, and now I just bloop right in there. Okay, so we are putting 2 little feetsies on these little anchor points just so that we can hold up this board on here. So that corner, and then I think, yeah. Okay, so 2 rows up on the right. Actually, 3. It's on the 3rd. So there, and then all the way, and then all the way up in the top corner. And that's just there to anchor the board and keep it connected to everything else. All right, we can move back in a little bit. I don't know if we need the microscope yet, but I'll probably want to flip to it. Don't need that. So that there, this there. We'll just solder that in place. It's going to anchor it down, and we're out of focus. Hello? 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 There we go. Okay, got him. Got him. Got him. Solder. Get that over here. I don't have a lot of soldering to do today. I know I'm drawing it out a little bit, but be nice if we had a more soldery day. Maybe on Friday we'll do a basics stream again. I need to do one of those. I enjoy the basics streams because then I can just hang out with y'all. Oh, I'm gonna have to flip this over because I'm actually I'm in the wrong direction right now. No, I never learned basic. I could probably pick it up if I tried. My BS in EE, and I designed embedded electronics for a time. Love Arduinos. Ain't nobody got time for look at all 10 registers I need just to write to make a pin and output. Exactly. I think AVRs have gotten a little bit more simple, but it's still ridiculous. And yep, BS and EE as well. And it's just silly. It's just silly the hoops you got to jump through. But you know, the hardcore microcontroller-y people will gatekeep that all day, and it's sick. It's sickening. It's stupid. It's sickening and it's stupid. We're a bunch of smart Alex. They're a dumb crowd sometimes. I'm just trying to like make this a little bit more organized. See if I can't pack it in, make it look good. Looks good on you. Which ones are the shoulders? I think the top 2 are. White one's the oddball. Yeah, I'll just do it like that. Okay. These little 30 gauge wires I can just pluck in order to strip them. We'll just do this. The old fingernail wire stripper, huh? I used to use my front teeth. I still catch myself doing that sometimes. It's not a good habit. Don't use your teeth to strip wires. It damages your teeth. Oh, this is the yellow. The yellow wire doesn't like to strip. All right. All right. What's up, Glitch? How you doing? How are we doing this? How are we doing this? Do I want to... I kind of want to, like, hold it still, but I don't think this clamp is going to... I don't think the vise is going to hold on to it. It's better if I can add inertia to what I'm holding in place. It doesn't really work. All right, so we just got to put it down on the desk. Down on the desk! All right, put that right there. What do you guys say? Program with anything else, Basic would probably annoy you. Probably. I know of Basic. I used to read Nuts and Bolts back in the day. What's up, Rayfred? How you doing? I think Rayfred, I think your name is somewhere in view on my new computer desk setup. I use the old boards in order to make a backdrop for my computer. You guys will see that eventually if we do gaming this Saturday. What just beeped at me? Oh my god. Really, shrimp salad? You're gonna do me like that? Shrimp salad? Oh my god. I'm just gonna blast it. Let's just blast it with insulin. Alright. For some reason, Twitch app stopped notifying me about your streams. Glad to see you live and kicking. They decided you didn't like my streams anymore, I guess. Hate it when they do that. Can't do nothing about it. Got my associates in computer science in 2002. Ended up working in the game industry for a few years. That's kind of cool. Got connected with one tech startup after another as a project manager. Good love hardware. Often much easier to troubleshoot hardware than software. Yes. Yes. But then when you get hardware driven by software, things get a little crazy. Get a little unhinged. But yeah, I've always been a hardware guru. I've always been screwing around with old science equipment and stuff. So I have a love for weird old antique-y kind of electronics, but also, modern-y kind of computery stuff. All right up my alley. I'm gonna pretend these wires because it'll make my job a little easier. But now I need to actually stand in order to get my face in there. It's not using the microscope right now. Viewing from about where you guys are. I gotta see, like, I have to get a good frame. I have to frame what I'm working on so that you guys can see what's going on properly, which means usually that I have a camera in my face that I'm trying to stay behind, and I'm like a mile away from what I'm working on. That's why the microscope helps me specifically. Those of you that people ask, like, what's the microscope setup? I want to do something like that. And it's like, I don't know if you do. Because there's a lot cheaper stuff, and there's a lot different stuff that's going to benefit other setups. The specifics of my setup are that I am broadcasting to you guys. So it needs certain stuff set up in a certain way. This is going to be sloppy. This is going to be gross. Gross, gross, gross. Here, let's get you guys a little closer. And then also focus the camera. Boop. There we go. There's a lot of shadows today. I'm finding it hard to see. Grab the wire, position, solder. Bada bing. Yep, next. Just kind of like get it into position. It is wire after all. It just bends. It just bends around. All right. Next. Do one of these. And this will just help us work with it. I can attach my buttons to this thing, and we can push the buttons, and then we'll work on the software. And everything's already hooked up for us to sniff out the serial signal. So we just have to retool our software in order to have a proper readout of all the different serial commands that are running around on the link. Yep. Okay. All right. Good enough. So our connections are as follows, and I'm going to check the voltage on this before I even start. I decided not to do wire wrapping. Those leads aren't long enough. Wire wrapping's good though, because then you get that strain relief. All right, so that's at 4 volts, so that's safe. I mean, it is allowing 10 amps, which is a little bit ridiculous, but that's okay. Get some light over here. Okay, so buttons. We put 2 buttons on this thing. That's where this comes in. Just a little helper thing that I built that has 2 buttons on it. Go figure. So, if I have, those connections are up here. Okay, so I can just connect the 2 middle ones to ground and then the 2 outside ones to the buttons. Let's see how simple that is to do. Well, I've got this. This will skip over one. I guess I'll do every other. It don't matter. The buttons just connect. I have to laugh. That little wire wrapping is becoming a helpful thing after being out of favor for so many years. Yeah, I've got literally within arm's reach. Yeah, it's right there. The Radio Shack wire wrapping tool. And when I ordered this thing off of Amazon, it came in a Radio Shack, like, you know, box. And then there's the little wire wrap stripping tool that I don't use. But yeah, wire wrapping is great for test setups. I don't use it like, you know, like I breadboard more often than not. I don't really jump to wire wrapping. Wire wrapping was very useful in Vietnam because you were able to have hundreds of layers of wires sitting beneath your board, and that gave you a higher circuit density than printed circuit boards at the time. You didn't have multi-layer printed circuit boards at the time. So for RF electronics, wire wrapping meant that you were able to have much more dense circuitry. From there to there. That's our ground. Now I need a wire that goes all the way over to ground. These are going to be our shoulder buttons so that we're able to we're able to activate the module, basically. I do have another row of holes there. I should take advantage of that. Use that way up close. And then that doesn't quite reach ground. Okay, so let's get the jumpers out. Yumpers. Get all my yumpers out. Oops, all 7400 series logic. I actually bought for $70 on eBay. I bought a big tray of 7400 series chips. I would love to get into that at one point. Why did you beep at me again? Oh, because you're done giving me 1 billion units of insulin. Shrimp salad. How many carbs could there possibly be in something like that? Using wiring up arcade controller buttons to microcontrollers and running signal lines on retro computer mods. Interesting. Huh. Yeah, when you, excuse me, sorry, hold on. I have all the acidity of the Red Bull suddenly hitting my cheeks. When you do a bodge job on a circuit board, wire wrap wire will stick to the board much better, and then you put a little bit of UV glue over it and activate it, and then it'll hold down that wire and make a semi-permanent bodge job. Bodge job was my James Bond character. Never really made it into the series. Bodge job. Well, I mean, I could just move this thing over to cater to that ground. I think I'm going to do that. I'm just going to move it over. There's a certain length in these little jumper wires that I just don't have. There. So positive's all the way out here. Ground is right here. And then these 2 are the buttons. So we got to go from these pins, this one and this one, to these. So I need that right now. I know people have advocated to me just building the wires as I need them. But it's called breadboard. Breadboard. I bought this thing. I bought this new thing but you know, I won't say how much it is, but there it is. That's the board. I'm not going to tell you guys what the price was. I just ate that cost. That makes 2 of them that I've bought just to reverse engineer it. You know, when you do stuff like this kind of expense happens, and I'm well acclimated to it. I've broken more expensive stuff in my day. In fact, 10 times more expensive than this was. I have been responsible for breaking. It happens, but it always hurts. All right. And everybody hurts sometimes. Everybody cries. That. And I'm about to. All right, let's see. What we got? I had something that I was going to say to FK the next time I saw him. Oh, yeah, you're dead! No, that wasn't it. That wasn't what I was going to say. I was going to say something else. I just forget. I forgot. Just one connection. And then, that's one problem with having the wires stick straight up. That I'm gonna keep running into them until they all break. Once we set this up, we'll be good. Bodge job. It's the wrong... No, it's a shoe. Oh, no, they already did that in Austin Powers. How did I get a cut? Yeah, he throws his coat. Bodge job. But it doesn't have any reach. It just kind of, like, flops on the ground. BODGE. Like, odd job, but he forgets to sharpen his hat. Why, you know, give yourself room? What do you mean? I'm currently crammed at the side of the desk because I got a steering wheel sitting right there. I have no space to work. That's just how it is. What else do we got here? One of these. And I'm using these tiny little boards because it's just what I have. It's just what I have. I don't need a lot of space to hook this up. We're basically putting 2 buttons onto the module and then powering it up. Yeah, I do. I know. I don't like to waste space. I'm a big guy. I need all the space for me, not the electronics. Just, I don't know. We don't need a lot of space. We don't need it. I've got enough of my habitat here to wander around in. Actually, I think I need another green one. I think the green is the appropriate length. Get back in there. Okay. Green. All right. So yeah, we're just hooking up the shoulder buttons because we have to. Oh, no, green's too long. I need a little bit less long than green. It's not blue. Blue's longer. Tan. Brown. Brown is way too long. White. Too long. What is the slightly smaller? This is like that cursed size that I just don't have, huh? I can make red work, but it's not quite. It's like 1 hole longer than that. This kit is starting to show its age, and I might retire it for a new one. Okay, there we go. So that's it. That's all the connections we had to make. So now I've got the 2 shoulder buttons, which are actually supposed to be the shifter buttons on the wheel. Well, yeah, and then the color-coded resistors are a whole nother language in and of themselves that I've not bothered to really learn comprehensively. I always look up the color bands on the resistors because it was antiquated technology when I learned it in school. In school, it was antiquated, so I just never bothered to really learn them all that much. It's like a decoder ring for electrical engineers, and I just wasn't having any of it. I didn't want to have to do that. All right, so wireless wheel module meet main controller. Let's hook this thing up and let's make sure that it works. So ground and power get hooked up. This stuff goes all off of my... Get out of my work area! I need space. I need room to think. I'm not going to pull up the model right now, but the computer project, I have the 750 watt power supply. I'm putting two 120 millimeter water blocks on. So it's going to be a water cooled power supply, and that'll sit in front of the motherboard. And then on top of it, I'm going to put what you're looking at right now, which is two 3 by 80 millimeter radiators that are going to sit at an angle like that and look kind of like a motor. So I'm currently trying to figure out all of the mechanical stuff behind that. And I got that little tiny 80 millimeter EK water block that's going to look like a carburetor. And I'm going to run tubes. It's going to be black silicon tubes that I'll probably have to use a lot of tie downs on in order to make them kind of hug the topology of that thing and look a little bit more like a motor. I've gone automotive with the build. It's going to be a water-cooled Titan, but it'll be weird, which is, you know, I can't build a normal computer, chat. I just can't do it. It hurt me to build an air-cooled setup. It actually physically hurt me. So I'm pivoting on the water cooling build and going totally psycho with all the parts that I had intended for a much larger box. I'm going to make a box that has what looks like a V6 sitting on top of it. My only regret about the whole thing is that I'm basically building a big open cathedral sitting on top of the computer. Because angling those radiators makes all of this open stuff. It's not smaller, I'm actually spreading out a little bit for once. I'm making a big open thing on top of the computer. I don't need your sass. I'm gonna turn this on. Boop. Oh dear God, that LED is bright. Oh, and it's on solidly. I don't know what's happening with that. Why is it on solid? Why are you on solid? I mean, it's power and it's ground. Hooked up properly, right? Go back over here. No smell. Everything seems okay. Let's power up the base station. Let me just check over my pinout, actually. Wireless wheel module. Pinout. They made the newer version of it like a plug-in card. Very weird. One second. What is this? I'm like, why did that come up? Why did this come up? Okay, all right, good. I was wondering it would be super fucking annoying if I suddenly pulled up a Pololu product that used the exact same protocol and could connect to the wireless wheel module. Shit like that has happened before, but... Hello? Can I... That's a PDF. All right. Okay, so yeah, we are connecting the right stuff. Paddle 2, paddle 1, status LED, we've got hooked on the module itself. We're not dealing with a rotary encoder right now, but yeah, just like that. Yeah, 30 volts, no more, no less. I guess it wants 3 volts. It'll complain about 4 and 5, but I'll bump the voltage down. It was totally okay with 4 though, because I mean you can hook up a lithium-ion battery to it. Okay, so Granite Devices controller has crashed. Cool. Okay. So Mercwheel software, Simucube, and then configuration tool. And then I can go to wireless wheels. I turn this thing on. And then I turn on the wireless wheel. Oh yeah, and I actually have to hook up the... I actually have to move the little pin over. Whoa, what is going on here, bud? This thing just like glitched out, man. Huh? What's going on here? Let's try that again. The wheel just like glitched out and did a full rotation, which is not what it's supposed to do. There it goes. I think one of the pins was unconnected. So that just boop, boop, booped on me. And now, yeah, it's the ghost of all the projects that I haven't finished. Yeah, so that's doing its spring to center thing. All right, all right, all right, all right. Ooh, I'm gonna work on the brightness on this camera. Maybe just point it right there. Okay, so now I can go to wireless wheels, clear list and rescan, and then I can power this thing up. I think I have to hit both shoulders at the same time or something. Well, the LED is just on solid. It should be doing more stuff. Why are you not functioning? Scan. This thing should be immediately looking for... All right, hold on. Let's check back in. I wonder if I flip the module around. I wonder if we're actually powering the LED directly. That might be what's going on, actually, to be honest. I've done worse. I don't think that would kill the module, but yeah, I flipped it. I flipped the module 180 degrees. God damn it. Ah, this is what happens when you work when you're tired. Okay, let's correct this. It should be a pretty quick correction. And hopefully having put 3 volts into the LED probably won't do anything, but I put, yeah. All right, let's redo it. Let us redo it. Power this off, power this off. If it's fucked up, then I don't know what I'll do with myself, but let's just do this real quick. So, tweezers. What I do with them? There. Stupid, stupid, stupid. Here, you guys come over here. I haven't seen a stream in a while. Have you fixed the module? This one? This one? This module? The one that I blew up? God damn it. No. I ordered another one. I had to order another one. Well, I'm glad this went directly to the LED and not to the circuit itself. Even though we were at the right voltage, so it is tolerant of that voltage. It's good that they have that little pin out there. It's something that a lot of places don't consider, and I'm not terribly sure that they considered it even, but just having a little bit of cognizance of the fact that you're not necessarily selling this to electronics professionals, and they'll do dumb shit like what I just did. At the drop of a hat. Okay, the ground is sinking to ground, and so all the heat is getting out of this. Oh, come on, man. Just solder, please. I want to undo this as fast as possible so I don't have to live with my embarrassment. But shit happens, and hopefully we didn't blow up another module. If I immediately tank this module, I am just going to be beside myself. And we'll end stream if this module doesn't work. That's the kind of stream that we'll have. I won't delete the VOD. I don't do that. But we will have a have a permadeath run. Permadeath module challenge, parentheses, impossible. All right, so I need that one. Where's my solder? There it is. All right. Oh, no, unfortunately, it wasn't a VOD. It's hard to capture stuff like that happening unless you plan it. Kind of like that one time that I accidentally opened a valve and ended up pissing brewing water all over my stream monitor. That was fun. That one wasn't planned, but that I got on camera. But yeah, little mistakes like that, hard to capture. And this was me working on the side to try to have something interesting to show for stream. And so I was plugging this thing into, because it wasn't even supposed to be that hardcore of work that I was doing. I was just figuring out what some of the packets were. And so I was like, all right, I need to get the RSSI to go down so that I can figure out that it is part of this packet. So I plugged in the battery, and I was like, all right, so we plug the battery in, and then I walk out of the room, and I put this thing on the couch in the other room, and then we see what the RSSI is. And so I plug it into the battery, and it just goes, psst, and I'm like, what was that noise? Apparently, I had plugged it into the 2S part of the battery, and I ended up giving it 8 volts instead of 4, and that's what cooked its goose. And that was all off stream. It wasn't a very dramatic death either. It just kind of fizzled. This ground is so sinky that I can't get any heat in there. So this goes there, this goes here. I knew something seemed like it was up when this thing was, the RF part was facing the wrong way. I should have caught on to that. But I'm tired. I'm tired today, guys. I've been sleeping right, so I took an Advil PM. And now I slept enough, but I'm feeling groggy as hell today. Any % rapid unscheduled disassembly. Yeah, exactly. Hey, what's up, Distant Cacophony? How's it going? I should check out Distant Cacophony streams. I've lurked a little bit, not as much. Yeah, permadeath stream module. Permadeath module stream. Everyone gets banned. Speedrun any %. I bought another one of these wireless wheel modules, and I really don't want to talk about how much money I've spent. I really don't want to talk about how much money I've spent on these things. Yeah, we're not gonna. Anyway, I bought 2 of them. This is number 2. And if I blow this thing up before even getting it to work, I'm just gonna end the stream. We're gonna have a 2-hour stream today. But if it still works, which it should, because we're not using 8 volts, using 4 volts on this thing. Like, I've lowered it to 3 volts on this thing. We get this thing to connect. We're gonna shuffle some code around, and we'll be able to sniff the entire packet, because we're 99% sure, or we're 99% through registering our fake module on this board, and that will enable me to finally play my summer car again, because we'll get all the button presses, and we'll be able to push the actual buttons that I'm pushing in order to get the gated shifter to work, and that way I'm not going to accidentally double shift and blow up the motor. So this is all for a $10 game. I'm into very advanced methods of cheating at games. For Mario Kart home circuit, we kind of abandoned it, and I would love to get back to it at some point. We were building an entire 1/24th scale hardcore RC car, and we're going to plug it into the AR of the Mario Kart home circuit in order to have a differential and a suspension in order to cheat at Mario Kart home circuit. It's like building a cockpit of a small Cessna just to play MS Flight Simulator 1.0. Well, you don't do that? I mean, part of it's also, we got a lot of content off of this, and having real car parts is pretty freaking cool. So, take it or leave it, chat. My summer car rally, you're not going to be able to do well on it unless you have a steering wheel. It doesn't need to be force feedback, but the amount of control that you need over that car, because it turns out it's a very good racing simulator, like a very good racing simulator. All right, all things considered, this should not explode now, and it should function. I'm going to turn the power supply back on. I turned it off in my anger. Wait for the power supply to come up. It takes a second. There it is. All right, power this on. Now we should get realistic feedback from the LED. There it is. Yeah, little blinkies instead of it just being on solid. Cool. All right, turn on the base station. Go over here. We don't talk about that price tag, and we go over to this guy. Aha! So here's our new button module. So we've connected to it. Battery says it's 3.01 volts, which is what we have this thing set to, sort of. It's like 0.1 volt off. But if I hit a button, beep, 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 bop, bop, bop. Wait, where's this one? Oh, one of the buttons is not working. Hold on. Might have connected it wrong. Whoa, whoa, whoa. Was that hot? Wait a minute. No, nothing's hot. Okay. I have that connected there. That connected there. And then ground from there to there. That's connected there and there. That's connected to that one. That's connected to that one. That should be hitting a button. Well, the other button works. That button works. It just doesn't know that both shoulders are connected. What is going on between those two? There's no reason why this one shouldn't work. Unless that's not the button that I think it is. I'm just gonna jiggle the cable a little bit here and hope it comes up. Yeah, I wonder why that's not working. Hold on. It works. It's just my connection to the button that's not great. So let me just take a look at this. Just take a quick look at this. Take a look at it. By the way, FK, we were listening to your very recent mix from Halloween of 2010. I need to find music to play at the beginning of stream, but it's hard because it's gonna seem like I'm copying other people. Paddle 1, paddle 2. Oh. So it's okay. That's a different button. What is that one? That's just a generic random button. I don't know which one that is. It should be showing up, but apparently the yeah, I know. I like the mixes on Mixcloud though, and it's just what I found. You know, it's somehow the music that you choose hasn't been grabbed by the Twitch copyright protection stuff. So yeah, there's a 2014. No, there's a more recent. It's like the 2021. Yeah, that's the most recent one. Okay. So it was the wrong button. Let me hook up to the other button. I need the other button. So what I need to do is go one hole further, so I need a different jumper. So I take out that jumper and I throw it, and then I grab a new one. I grab a new one, grab a blue, we hook the blue up. Grab the blue. Yes. All right. The blue one goes to that one over there. Sorry, I gotta lean in front of you guys. Down in front. Get your stupid dumb face out of my way. I'm trying to watch O Bother. There it goes. Okay. Alright, let's try that. What was the old sound system from like Motion Nightclub? Function 1? Is that the one? Oh god, Motion Nightclub. I still have a guest list like card in my wallet. Oh, that was at Cielo. That's cool. Sir, you're blocking my view. Move that gigantic cotton candy. All right, let's see. We're going here. Sorry, I had to blah, 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 blah in order to... The button still doesn't work. Wait, neither button is working. What have I done? What have I done? Rescan. Give me my wireless wheel. What happened? Stopped working. I might have bumped the wire that it didn't like. Wait, the LED isn't even on. What's happening here? Oh, my ground wire disconnected. Whoops! DJ booth sounds incredible. That's cool. Yeah, I'm pretty sure I have tinnitus because of fucking Motion Nightclub. It's not an itis, chat. It's not tinnitus. It's not an itis. An itis has a different connotation. It's tinnitus. You can't contract it virally, you know? You don't got the itis. Yes, this is the floatiest of grounds. It's an RF ground. Floating isolated RF ground. It's just a ground suggestion. Just gonna get some solder over there. Okay, there, that's connected. All right. Yeah. Wasn't that like a meme that went around recently? It was a Ziploc bag full of dirt inside of an electrical cabinet. Pretty sure I remember that. All right, power back on. Bada bing. All right, Mac connected. 2.96 volts. Man, we're really dropping off lately. And then we go to the overview so we can see little buttons. Button. Yes, there they are. Both shoulder buttons. Those are those two little beebly boppies down there. These little guys over there. So those are the shoulder buttons. I can hit them at the same time in order to power this thing on and off in case it like goes to sleep. But what that means is that we now have all of the components that are necessary in order to observe the full nose to tail procedure that's going to go on here. And I have a particular idea of how this is going to look when we put it together. We've got to make our Arduino sniff. It's got to sniff. It's got a sniffity sniff. It's got to sniff both lines as a receive line. So the transmit lines we don't care about. We're not talking back anymore. Now we are in the closet looking at I don't know. There's all kinds of weird shit that I can say. I'm not going to go into that. We are observing. Yeah, we got to snort the lines. There we go. Wait a minute. That might get banned. All right, so we can leave this running or close it if we're nice. We'll just leave it running. We'll just leave everything running. I'm gonna take a potty break and then we'll be back. And then we're gonna do some Arduino stuff. We're gonna start a new program here. I'm gonna start a new program with hookers and blow. I don't know, man. All right. Anyway, yeah, we're gonna take this test program and we're gonna move code over to the new one, deactivate parts of it, do a lot of deleting, make another serial connection, leave all the definitions of the packets, and then we'll be able to poop out what's actually going on here as the thing boots up. So we'll work on that in just a minute. But first, bio break. So I'm gonna put up a BRB overlays, and then I gotta put up a BRB overlay, which is that one. No, that's not. What is that? What is that doing on here? What is that? No, that's not BR. Okay, can we get that on? Can we? Hello? Can I get the booth? Hey, booth. Can you guys turn that off for me? Okay. All right. They got it. All right. So I'll be right back. I'll put this thing going on. Burp. Bop. Somewhere over. Oh wait. Here. I guess I'll just leave this view up. So I'll be right back. Oh, I don't do that genre identification stuff. I just don't do it. There's too much. It's too much. It's too much. You don't do it. I don't like to get into an argument every time I mention something, so I don't do genres. Blue Tech. Okay. FK Productions would know. This is his mix. I never listen to a lot of Cone. I generally just got stuck in the Simon Posford. Anything Simon Posford produces, I love. All right, so here's the deal. Side dub, there you go. Yeah, that's, I know what you mean, I'm just saying. But notice how there's like 15 different things you can look up in order to get something that sounds similar. It's a mess. It's a mess, but it's a fun mess. Sybient, Psydub, Blue Tech, Cone. Blue Tech and Cone are the artists that are mixing, you know, going from one to the other. But yeah, Psydub, Sybient. All right, it is a dub genre because it's super chill. Finding diamonds in a coal mine. Yeah, what's that meme with the old guy that gives up on digging? We need to listen in on this serial line. We need to listen in on it. We need to figure out what's going on because we got all the button presses on there. Oh yeah, one thing was finding music that works in the genre with similar keys. I did do a couple skips because the flutes were like off key and annoying me. Even though the rest of the song fit perfectly, they decided to put like some sour note flutes in it. I'm just like, I can't, because I can barely hear I can barely hear the music when I turn it on, just because I don't want this mic picking it up. So, so I get to listen to only the stuff that comes through at the very top of the track. And it was just like sour flutes. I got the Omnipods. I got them, and I did a bunch of reading on them on Monday to try to learn how they work and how to get them functioning and operating and as my new insulin pump. I'm not using it yet because I want to build up extra supplies. The insurance companies love to only provide exactly as many of these things as you need, but if anything goes wrong, the manufacturer is like, throw it out. They're like, I don't give a fuck. Just throw it out. Fuck. Shit, why'd you fuck call me? Just fuck throw it out. Fuck. Like, they don't care. They just discard these things left and right. Whereas the insurance company gives you exactly as much as you need to get to the end of the month, because for some reason, I guess that's how we manage diabetes these days, is that nothing is disposable. And if your insulin goes bad, you have to use it. I guess they just algorithmically know how much they can push your already stressed out diabetic in order to get them to manage themselves and stop bothering you. But anyway, the way this thing works, this is the Omnipod 5. You load this thing up with insulin, at which point you start a 2-hour timer, after which this thing deactivates itself permanently. Isn't that awesome? Anyway, you load this thing up with 200 units of insulin, which the thing that I have currently has 300, and I replace these sets every 2.5 days about. This thing is like every 2-ish days, a little less than that, you would replace it. But you put this on your body, and this thing contains 200 units of insulin. In this is a clockwork mechanism that is activated by a piece of memory wire. That memory wire contracts, and it clicks over a certain fractional amount of a unit of insulin. And so in that scheme, this thing is able to administer insulin to you while also being very compact and sort of discreet, right? I don't have to have a metal clip on me that's going to stab my fucking leg if I move the wrong way in bed. Nor do I have the doorknob detector, which is this device right here. This thing is good at finding cabinet slides and doorknobs and just literally everything in a room that it can find. So I'm excited to switch over to this thing, and I started to read up on how to use it. The amount of warnings in the how-tos on this thing is absolutely staggering. But the way this thing works is that you fill it up with insulin, starts a 2-hour timer, you put it next to your phone, register the device, put the thing on your body, removing this plastic clip, and then you tell it to start. And when you tell it to start, it auto-injects a cannula needle into you. So it actually has there's a plastic tube. So this thing, a syringe will poke out of it and then retract and leave behind a plastic tube that connects to the insulin reservoir inside of this thing. This thing is also able to communicate with my constant glucose monitor. So if my phone is too far away, this will continue to operate on the parameters that you've set into it. It will get glucose levels and react to the glucose levels appropriately. One problem. This is an Android 6, or a Pixel 6. It works on Android, what, 12 or some shit like that? This doesn't work with that. The software doesn't work. I learned that yesterday after going through all the shit to try to get these. Now I'm going to give it a couple months until I start this thing, because I want to have extra supplies. I'm greedy like that. And I've got so many supplies for this thing. So I'm going to wait a little while. They might come out with software that works with this thing. But in working with the phone, you have to lock down the phone. You have to lock down the phone, and you can't do any developer stuff. You can't install APKs on the side. You can't root the phone. Otherwise, the software will detect it, and it'll keep you from using the pump. So in that same breath as my learning about that, I also discovered that the We Will Not Wait, the diabetes hacker people working on the Android Pancreas project, have a system to use the Omnipod 5. It's currently in the dev. It'll be pushed out to the main program soon. Omnipod 5, the Dexcom, a smartwatch, all of the above, all integrated with one another. I just need to make sure that my doctor can get the logs from it, and I need to install all the APKs and stuff like that. So I've just started learning about it, but apparently I'm going to be using Looper and the open source diabetes management stuff with the latest and greatest Omnipod 5, because the medical company does not support my phone's operating system, but the hackers do. What kind of a world have we ushered ourselves into here? I mean, I guess it's all good that I can do that. I'm very glad that I have an avenue to explore, because I spent so much goddamn money on a phone that I thought would last a long time. Anonymous Cheer, thank you for the 2 bits. That gets me a little bit closer to affording the care and level management that I've become accustomed to. But yeah, I think I'm going to use the, I think I'm going to go We Will Not Wait. I think I'm going to go with the, all that other stuff. Pixel 6 is kind of crap. I don't know any of the other phones. This isn't breaking. I've had a great time with this. You know, it unlocks in a pretty timely manner all the time. I have not had any troubles with this, to be honest. I know there are a lot of complaints, and I'm not totally aware of all of them, but I mean, I came to this from an HTC 10, so it feels like the modern world when I use it. I don't know. I like it so far. I know a lot of people have had a lot of complaints about it, though, so I'm aware of them, but there are bugs, but overall it's a very solid phone. Yeah, I know people have had trouble with the unlocking thing. I have not. I have not had those troubles yet. We are not the same. I don't have troubles. Yeah, the reservoir fill is on this side of the thing, and you know that's an anti-consumer design choice right there. They could have put it on the back, and then you could access it and refill your reservoir while this thing is still installed. And they put it there. And I think that was an intentional design choice that's sort of anti-user. There's also a reset button, or a shut up button. It'll stop it from doing an alarm on the back. But this thing has like a beeper and a buzzer in it. But these are disposable. I have like 5, 10, 15, 20, 20. I have like 30 of these things right now, which is kind of cool. But I do wish I could pump it up and do a second use out of this thing. And there might be ways to do that. There might be ways to do that. I haven't explored that yet. I know with all of my other supplies, I can double up on the supplies, and that's how I eventually have, you know, enough so that if there's a supply chain issue, I never heard of that term before today, supply chain issue. If I have a supply chain issue, I have a stock, like a capacitor that can absorb that. I don't have that yet with this thing. My next prescription is up in, I think it's like June or July. No, what the fuck month is it? It's 2 months from now. I can go again. All right. Anyway, yeah. So I gotta learn the open source diabetes care and management stuff, which is it's overall more complicated and it's actually more capable. I've read, at least on Reddit, of some people saying, yeah, I set up all that open source stuff and now I don't bolus. Which, that sounds like nothing to you guys. That sounds like nothing to you guys. But to be able to walk up to food and go, I will have an food, please, and eat the food and not do anything before or after, or even have the slightest bit of cognizance about exactly how many carbohydrates are in that food, is completely wild and alien to me. It's something that I would cry with joy about doing. And apparently people have achieved that level of control. I don't think I will, just because of the amount of resistance that I have to insulin. But it just something to be able to have something completely automating all of this stuff that I've been doing since I was 9 years old is insane. That's insane. So I'm hoping that the open source stuff I can get working without too much issue on the new phone, and then start using that new pump. And I'll just have my phone to control the pump instead of having to whip out something and getting all these weird comments about having a pager. I'm excited about that. That's why I'm talking about it. All right, anyway, we got some software stuff to do. We got the button, the wireless wheel modules hooked up to buttons, and those buttons we can press in order to assert a button press on the overall system, whatever. We know what a lot of the packets look like because the Blue Gecko module dictates a lot of what's going on here. This is the Bluetooth Silicon Labs Bluetooth whatever, right? Not examples. We were looking up examples to see if we could find the connection procedure, but apparently SI Labs is like, download our software and use our software to do it. All right. Anyway, this is what all the packets are in this document here. So we know what a lot of these packets are and what they're doing. Now we need to set up a sniffer. So instead of doing anything with the code that we've already got, I'm going to go File New. I'm going to save a new Arduino program. This one's going to go with everything else. So this will go in, I'll go to the desktop where I have a shortcut to my file server. Where did that go? File server. Hello? Hello? Where did my file server go? What is that folder? Let's see. Not libraries. That would be stream short. Ah, there it is. Okay. So in here, I've got the Mercwheel project. Mercwheel. And then I guess I'll just put it in Arduino, and this will be, is my cough really, my cough is almost completely gone. It's just I'm using my my vocal cords a lot right now, and so it tends to like tickle stuff. It tickles stuff. This would be our sniffer. This is our sniffer program. Oh, we got another yeah, we got a lot of diabetics here, and it's probably because I'm always bitching about it. I'm not fairly closed off about my diabetes, but I also have this trouble where I'm really bad at connecting with other diabetics. I found the Reddit diabetics, and they had an IRC channel, and so I met a bunch of people and I learned a bunch of stuff. But then after that, I've been kind of closed off from it. I need to kind of reconnect and figure out what the state of the art is and what everybody's doing. Diagnosed with type 2 a couple years ago. Since then, I've been amazed at how many people I know have one or the other. Yeah, I got all of the one and a little bit of the other. My body weight sucks right now, guys. I gotta lose weight or I'm gonna die. So I gotta figure that one out soon. But that's causing insulin resistance, so my type 1 diabetes is a little bit exacerbated about that. It kind of hates it. Anyway, all right, setup and loop. So what are we doing here? Well, we're going to be a good programmer. We're going to comment on what we're doing. Wait, which direction do we go in? Like that? Yeah, there we go. All right, so sniffer. Based on our test program uses as hold on. It's not even like a physiological cough. It's like a mental cough. I don't know what it is about that. SI Labs Blue Gecko module on the Granite Devices SimuCube. We observe TXRX between the base station and the Blue Gecko module. All packets conform to the API, which is, I always do this stuff because it's super important when you come back to your code after a year and go, what the fuck? What is this? So there's the API. Using software serial on 2 pins, a teensy 3.2. Then the normal USB serial to print out verbose packet info. Infall, we'll leave it. All right, so that's it. That's all we're doing. So the first thing that we're gonna do is set up a billion serial things. And so we need a couple different parameters in here. I don't think we're gonna do a variable for serial speed because everything's 115200. Everything's gonna be 115200. The pins, I guess we could probably set up with variables. It doesn't really matter that much. I mean, this is a test program, so we don't need to have a lot of different definitions of everything on here. Why is my scroll wheel not running in the right direction? All right, all of these packets are unnecessary. All these constant definitions, we will define them down in our state machine that's going to read all this stuff. So we need this stuff in the input buffer. So we'll grab that. We don't need our complex timer because we're not setting up any timers. Don't need an active timer array. Boot, discovery, packet advance, none of that is necessary. Packet advance is just used to bring us through like an algorithmic process of sending a couple packets in order to register ourselves as the module. This program is all about faking it. We fake everything we can in order to make sure that we register ourselves as a wireless Bluetooth module, and it almost works. We get to the point where it looks like everything is connected as it should be, but when we send a button press packet, nothing happens. So something is going on here. That's why I spent $50. So if we have like 1 or 2 packets that we didn't know about, that will be a success, and those packets will then be referred to as the $50 packets. It'll be a $25 packet if there's 2. We'll distribute the cost amongst them. Hopefully, Amogus, hopefully it's more than 2 packets, and I fully justify it. The more packets there are, the more distributed the cost is. If this is 1 packet that costs $52, and it's something that we could have looked up in the data sheet if I just had the wherewithal to look at it, then I'm gonna be mad. I'm gonna be mad at myself for being lazy. Time is money, I guess. I don't know. But if I could have read a data sheet to figure out what this packet should be, I think my theory is that this packet has nothing to do with the Blue Gecko module, and it's something that Granite Devices made up in order to tell the base station that we're ready for the custom packets. I think that's what we're going to find, but that's my theory. It's just a theory. So anyway, we need to tool up our entire program in order to just listen in on the TX and the RX. So we got a bunch of weird stuff at the beginning of our program, and that's due to the custom timing library that I'm using in this code. It's somebody else's timer, but it has a method by which you can have another device set a couple different timers, and they run independently of the thread that's moving. So we set it up that way. It probably would have been just as much work for me to make up my own timer. Like if we just filled an array with values and subtracted from the values until they were 0, that would have worked too. But I used the library, and I don't know. It has these weird functions that we have to define ahead of our loops, which I don't like. I don't know. It's something that you find in other, like in Python, you put all your functions ahead of your main loop and stuff. I'm used to the old Arduino system where you've got your setup and your loop. It's like variables, setup, loop, and then your functions are below that. That's what I'm used to. That's how I code. I guess it doesn't really matter. But anyway, all right, setup. Serial begin, 115200. Serial 2 begin, 115200. So we need these in our setup. But then we also need another serial port. So we need to look up the teensy 3. Hold on. We need to look up the teensy 3.2 software serial. That or I can move one of the pins. Either or. Right now, we're using serial and serial 2. I guess I'll just move one of the pins. I guess I'll just do that. Instead of, because then we don't need to use software serial. I was going to use software serial and define pins, but teensy 3.2 pinout. There's our buddy right here. They actually provide you with a cardboard card of these pinouts when you buy the product. PJRC.com, man. If I could get a sponsorship from him, even without a sponsorship, it's just some guy who makes these awesome microcontrollers that are super duper duper capable. They're insanely capable. Much, much faster than a normal Arduino. More pins, more complexity if you let yourself get into that. And just insane capability. The teensy line has already been famous for being the easy way to make a keyboard, because you literally just choose a keyboard from a pull-down menu. But anyway, we're at teensy 3.2, which is getting old, but it's not that old. And we've got serial and serial 2 used. So many people are sketched out by the website. Yeah, it's not a very, it's a little rudimentary, but that's fine. It doesn't need to be fancy, you know? I buy all the microcontrollers that I use directly from this guy. I love these things. They're super good. It's what I used in that LED headgear in order to control over 1,000 LEDs on a piece of headwear, the topiary sphere that I wore on my head. It's hanging in the corner of the shop. All right, so serial. Well, there's RX1 and TX1. RX2 and TX2 we're using. So we're going to move pin 10 to pin 7. I'm just going to make a note of that. Three. So we are using serial, serial 2, serial 3. So this would be to the PC. This one is the... Which one is that? That one's base to module. And then this one is module to base. So then that one is RX. This one is TX. Man, I mean, I could call them something else like send and receive, but remember, we are looking at this within the context. This is like grammar, right? This is a lesson in grammar. What we're programming. Get it? Oh, I'm so sorry. Anyway, we're looking at this within the context of being the module. We are the module. So we keep it within that sort of, I guess, tense, if you will, within that voice. We are the module. RX and TX is in relation to us. What is that twisted? It's a Roboz emote, of course. God, that is a weird one. God, that is a weird one. All right, so serial 2, serial 3 begin, and that's all we need. That's all we need. Yeah. I am one with the module. I know. I'm gonna try. I'll see if I can do one Wednesday. I'm gonna try to go to a salon. If I come back with like a mohawk, maybe I'll do that haircut where you keep it like super long and then you shave the sides. That only works if you've got like a muscular face. You need like a muscle head in order to do that. No, what I've got going on here is a beehive cut. There we go. Oh, now I've got the bowl cut. Yes, perfect. All right. Anyway, I'll do the Ewan McGregor rat tail from the Phantom Menace. All right, so what are we doing inside of our main loop? Rob's emotes never disappoint. He does some weird stuff. Inside of our main loop, all we're going to do is get packet, and then I guess we do respond packet. So first of all, we need to get the packet, and this is a function that I created from my other code. Yeah, the burp and the nose emote. The spiky. Yeah, I'm going to get frosted tips. We're going to go all the way. We're going to rewind time, and I'm going to make up for the time I missed when I was studying engineering. So I'm going to go frosted tips and start listening to Linkin Park. All right, so anyway, go back over to here. We're going back to our code. So we need the get packet function. And that'll enable us to load a packet into our buffer. The sniffer mode is low effort. So is the burp, but the burp he managed to make look like something all right. Listen, the other emotes are also low effort. I hate to break it to you. They are just screen caps of Star Citizen face over IP. So I just did my haircut, waited too long, and ponytail, felt people kept staring at it. I could probably do a top knot. Old Linus Tech Tips. What? All right, so get packet. We'll also probably want clear packet to clear a buffer. Oh yeah, and we need all those variables, don't we? That's the input buffer. Print packet we're going to need. So let's get packet and print packet right now. The two first packet functions. Print packet, get packet. Once we get packet, it's going to load it up into our variables. So we've got the four identification variables as well as the input buffer. So get packet and then respond packet. That's all we're going to need. We have two functions that are going to define this thing, but then those functions have sub-functions. It's just a thing. It's just a thing. We got to do the thing with the thing. At least this is relatively simple in the grand scheme of things. I have most of the stuff already properly. See, we're not going to any reply functions we don't need. So clear the packet we're probably going to need just so that our loop doesn't continuously print stuff out. So print the packet, get the packet, clear the packet, pack the packet, pickled pepper packet, reading. Okay, where are we? Up. Puppies. Set timer don't need. Send success don't need. Send anything we don't need. Print the packet we got. Get the packet we got. Intercept sequence we don't need. Check discovery we don't need. The rest of it is this guy right here. And this is our big state machine. And we're going to expand on the state machine, by the way. Who dat? Louis! I mentioned Louis earlier. I'll catch you guys up in just a sec. Holy shit, this is a big function. Respond packet is the next one that we got. Check disco. Yeah, we're checking disco. Okay, let me explain to the lunatics what's going on here. How's it going, Louis? I've meant to lurk in a Louis stream lately. I saw him on Djibouti's show a couple times recently. I've just been a little busy. Things is going crazy around here. I mean, I've been working. What we're working on right now is my very elaborate way to cheat at My Summer Car. It's not really cheating. My Summer Car is actually a really good car. It's got a lot of really, there's something in my eye immediately. Lou, I think when Lou raided, he kicked a little bit of dust in my eye. I think that's what happened. Damn it. God, he's always unfair like that. Anyway, how you guys doing? So this is a really elaborate way of cheating in My Summer Car. What I'm doing is I'm building a simulator setup out of other people's industrial garbage and car parts. So actual car parts, except for the shifter at this point. The original is, I'm a dusty boy. The original shifter of this thing was out of an EMW. What is wrong with me? It's out of a BMW M3, the Steptronic shifter thing, which is a fully electronic piece. You just pull this out of a car. Just go find a car and pull it out, and you can hook this up to a setup and have a sequential shifter. but the sequential shifter was not very good. I would accidentally double shift and blow up the motor in my summer car, which, by the way, putting the car together represents more than a couple hours, more than like 3 hours of actual work in game to produce, and then it just pops when you shift into the wrong gear. So we found STL files. We found something to 3D print in order to create my own 8-gated shifter. The problem is that added a bunch of buttons to my setup, and so now we're actually working with the setup in order to hack it and put more buttons on the thing. But what I have over here, and you can't really see it right now, this is a bunch of pedals out of a BMW M3, and I bought them on eBay for $160. And then Turbo Nad, who's a British streamer he's a really good guy. He's really cool. He went out and he bought the same pedals for like $20 British money. So it's like, God damn it. Anyway, I have a load cell on the brake, and then I have springs and sensors on the other two. The gas pedal for the BMW, by the way, is completely digital. So that thing it actually works like a potentiometer, and it's totally easy to do and like cool to implement. It's great. You just give it 5 volts and you get a wonderful signal out of the thing. The steering wheel, oh, it's him. Furby. Don't make eye contact. Just don't make eye contact. We can't. Okay. All right. Okay. I think we made it out of that one, chat. I think we made it out. Anyway, so the steering wheel itself was something that I bought before I even started streaming. So that was like 8 years ago. It was like 100 years ago. Before I even started streaming, I bought this wheel because I thought I was going to build something with the Open Wheel project. Oh my God. If you guys don't know, that's an actual... So like streamers that have like bits rewards in order to make noises will have like an application that they're running, and it's all digital, right? This is an actual random fart noise maker that we have logging into the Twitch API, and when you guys redeem channel points, it will set off one of 9 random farts that we're putting through a nice quality Harman Kardon speaker. And it's actually quite loud. So you're listening to that over my lavalier microphone in the real world. It's actually quite annoying. That's the kind of stuff we get up to here. Anyway, so I bought this wheel because it has a bunch of buttons on the outside and it has the paddle shifters. So I thought that would be cool. And then I discovered that these buttons are multiplexed in a weird way. It's like it activates these 2 buttons and then reads from one wire, and then that wire activates these. It's a really weird way of doing things. So there's a circuit board on here. We looked at it and we found out that there was a chip on there that speaks what's called the LIN bus, which is the local interconnect network. It's an automotive thing that allows you to speak to a bunch of different devices with only one wire. And so we reverse engineered that, and we were able to hack into the wheel in order to get all of these button presses and have them come back to the Granite Devices SimuCube. Granite Devices SimuCube is an offshoot of the Open Wheel project. What that allows you to do is use the Granite Devices motor controller, which is like they call it the Swiss Army knife of motor controls, which means I can buy a random motor off of eBay and characterize it and then configure it and use it as a direct drive steering wheel. So I don't have to spend $5,000 in order to make this happen. Now, this is a multi-$1,000 motor that was cut out of a rotary setup at an industrial something or other and replaced, because if your motor breaks, if you run stuff until it breaks in a factory, you're fucking up. You're spending way more money than you should, right? So you pull that stuff out before its service life is over and you replace it, and then it ends up on a shelf, and then some shady person comes along and grabs it and puts it up on eBay, and then I buy it. And I attach my own encoder to the back of it and hook it up to a Granite Devices SimuCube, and then I've got a 2.5 horsepower motor hooked up to my hands. Pretty cool. So anyway, we got a lot of real car parts in here, and I've made everything on here speak the LIN bus, which communicates with this microcontroller that's on the Granite Devices controller, this thing that I've added on. That pushes buttons or twists knobs, quote unquote, in order to make the controls, the joystick controls, activate properly, right? The problem with that is there's only so many buttons that we can configure in this thing without going digital. So here we are going digital. Granite Devices has not told us anything about how to go digital. What you need to do is you need to buy their $100, 2 boards for $100. One's a receiver module that plugs directly into the board. The other one, you hook up to a battery and you put in the steering wheel. So your steering wheels are now all battery-operated devices that you need to recharge. Well, I wasn't about to do that. I was not going to buy like 2 of these things and hook them up to the various random pieces of my simulator setup. Oh, I did buy 2 of them. Damn it. I accidentally connected this one to too many volts and I blew it up. So, oh well, that happens sometimes, man. You gotta break a couple eggs, right? You gotta pass some eggs. You gotta egg up some egg. Anyway, so I broke an egg, bought a new one of these modules. That's where we are today. We've been able to reverse engineer the digital protocol that the module speaks to the base station up to the point where we are almost completely emulating a module. That's what this is supposed to do. What we're doing right now is we're turning this into a package sniffer. Yeah, you got to break some legs to make an omelet. I think that's what I learned from Louie's cooking stream. That's right. That and how to make jalapeno poppers, which I should do more often. Ah! God, what have you guys been eating? Anyway, this thing right here, we're turning into a packet sniffer. So we're going to change up the pinout a little bit, and we're going to listen up on the TX and the RX, now that I've spent all the fucking money on this fucking module here, so that we can actually figure out what all the packets are running through this thing. We got through 90% of it. We got this thing up to the point where this fakes being a module all the way up until we're in a mode where it looks like it should be receiving button presses, but when we send a button press, it doesn't do anything. So I think there's still 1 or 2 more signals that we need to get out of the thing. And then I'll be able to launch into a whole bunch of just basically taking 2 programs and just pushing them together. And then we add the pins here that speak to TX and RX, and then my whole wheel system works. So if things go well, we might be able to do a My Summer Car stream on Saturday. No promises. I don't know how much software this is really going to take. It might just be pulling modules in from different places if we can get it to work properly. But I'm a little worried because we got this thing all the way up to the point where it looks like it's ready to go, but it's not actually responding to any of the button press packets that we send it. If we can send a button press packet, that means I can make this thing look at that TX and RX and configure itself, request the status of buttons from my hardware, and then send a packet that represents the buttons being pushed. That's it. That's all we need to do. Very simple, right? Real stinking simple. I hope you guys had a good stream over there at Lou's. Luciferous, thank you so much for the 14 months. I really appreciate the resub. So yeah, we've been working with that, right? Whew. That was explaining the projects around here takes half of the stream, I swear, nowadays. You know, what we used to have around here is a board on the wall that would burn the names of the subscribers onto itself. It had a blue laser on it and everything. We're going to get back to that project. I'm trying to get this stuff done so that we can work on the board again and get that up and running. Because, yeah, numbers have been tapering off. Numbers have been tapering off, and I need numbers. I need numbers. The numbers need to go up. It is a complicated project, yes. And it's gotten a little too complicated. It was supposed to be a lot simpler than it actually is. That's always the way these things go. And I'm not pulling punches for Twitch. I'm keeping it complicated. If we don't end up getting a lot of this software stuff done, what I would like to do is on Friday... Like a gnat just went by. I got like occasionally a gnat goes by, and I've looked everywhere for why they're around. There's no food garbage here. I don't know what it is. Anyway, so if we don't get around to doing if I don't get all the software stuff figured out, on Friday I want to do like an Arduino basics stream, and I'll come up with something that we can do that'll like, you know, flex our muscles a little bit, but also keep it nice and simple. You know, something you guys can follow along with. But that's only if this stuff doesn't take off. So anyway, let's get back to what we were doing. So I was cutting and pasting stuff into the main loop of the project. We have this giant switch case scenario going on, and maybe this is the wrong way to do it. I probably should have used like lookup tables or something like that. There's always different ways to program stuff. But what we have is a system by which we can make the packet. There's like 2 ID numbers in the packet, and we're separating them out initially. We'll smush them back together, and then we run it through this giant switch case, And if we get a packet that we know, we can have it print stuff out. Anywhere we're sending something like this, we need to turn that into a receive. So EVT system boot. What happens is initially we get a system reset and then a system boot, right? And when the reply comes for the system boot, we're sending it out in the other program. In this program, we need to just print it out. So what I need to do is I need to go to the data sheet and I need to look up what EVT system boot looks like. So Control F, bop, there it is, EVT system boot. So this is a 1-0. So the class and the method, 0100. So we take our 0101, we're going to make one that's 0100, and we'll print out that it's the event system boot. So we got to go through the packets and do that to basically every one of these. And we just print EVT system boot. And then we need to clear the packet afterwards. Clear. Blah, blah, blah. So this is going to take me a little while to put together. But once we do, we will have a system that will print out the identification of all of these packets. We actually also want to print the whole packet. Yeah. And we need to actually make something that tells us what serial port this is coming through on. So we're going to get rid of all the definitions. The receive and sends are out of here. What I'll have is I'll have 3 lines per packet. So it's going to be line 1 will be send or receive. Line 2 is the identification. Line 3 is a full printout of the packet. That's what we're going to do. Capiche? I need to get a haircut. Also, I need to game with Louis. We need to find like a maybe not a Wreckfest. Wreckfest gets too shouty. We need to find a game. Although Louis his time is already stretched. So we don't need any send successes. Let me get the print packet. And that's actually coming from down here. So what happens if we don't know the packet? We go to default, the default condition. So we can do serial.println, and we can say, I don't know. And then we can have it then print the packet, and we'll not send a success. Any unknown packet, I have the program just like sending like a success type. So print packet, clear packet is what we want after any of our prints in this. We got a lot of complicated stuff going on here. This is gonna simplify it a little bit, and then we'll be able to actually like, ooh, look at what's going on. Look at what it's saying. So anyway, that's what we're doing here. I don't mind if you guys leave. You can go. You don't need to pay attention to this weird stuff that I'm doing. All right, so if we get an event system boot, print the packet, clear the packet, and then I'm going to need to make something that figures out, that basically scans send and receive for packets, I guess. How's that going to work? We're going to need 2 buffers, I guess. Unless I do maybe like bool. Send, receive. No. TXRX is equal to 0. Is that a good way to do it? If I do like a Boolean, depending on which I'm scanning for. I mean, we're going to scan for one and then the other. And if we get a packet, then we need to print out that it's send or receive. I don't want to add an if statement to my switch case. That might be what we need to do. We might need an if statement on the switch case. Or I could just do that ahead of... No, because that's case 0. I'm just here for the background sounds while adding survey points to Google Earth. All right. I got the Luciferous Prime, right? Thank you guys for the follows. I've turned off the follow notifications just so that, like, you know, I don't know. I don't like it when I follow a channel and they start setting off air horns and like confetti comes down. They're like, "Whoa, thank you for following." And it's like, I just followed, dude. Don't freak out. If CLID is equal to no, is not equal to greater than nothing, greater than 0. I can do greater than 0 and what was it called? TXRX is equal to 0. It's kind of a weird, it's kind of an awkward way to do it, right? Actually, if CLID is greater than 0, if TXRX serial print line TX. Wait, is that correct? Which one did I define as which? 0 is equal to TX. All right. So 0 is equal to TX. So that would be RX. RX. And then we do. No. What was that? What the hell? Have I forgotten how to code? Got a big Louis raid and I forget how to freaking code. If TX RX else. Print line TX. There you go. So that'll just tell us TXRX, and then we do the next one, the next one, the next one. One sec. You're right. You're right. But I can't use those. I can't use that. So I do just direction. No, that's also something. Is TX. There we go. Is text. So what are we going to do? Our packet's been cleared. We're going to look to see if there's a packet available. If it is, then we'll set it in that direction. So when we receive serial, we're going to need... Oh, this is going to get weird. We're going to need to, like, I guess we're going to make it cognizant of which direction it's going. If we don't receive a packet, then our IDs are all going to be set to 0. We don't worry about what's in the buffer. The buffer is just going to be garbage at all times, but we look to see whether or not we have a proper address. PyroAsp subbing with 40 months. Holy shit, dude, 40 months. I added that vibe emote just for Pyro. Everyone else can use it too. I didn't just add it for him. Just add it for him. It's not really his emote, you know. You don't do that. If isTX is true, print RX. Yeah, you're right. IsTX, TX, otherwise it's RX. There, flip it around. We're just gonna flip it until we get it right. Oh my God, I can't believe Uncle Phil used Pyro's emote. How cringe. Anyway, it's not. All right. So if CLID is greater than 0, so we have an ID, there's information in there and we have a packet that's meaningful, then we print out whether it's TX or RX, and then it goes through the gauntlet of the switch case to figure out whether or not it's something. If it isn't, if it is 0, then we just keep going down. What's this for? Oh God. Banned. I did explain this comprehensively when Louis raided a little bit ago, but what we're trying to do is fake that we are a wireless Bluetooth module connected to this simulation controller so that we can push buttons digitally because we've run out of buttons. So we are looking at the SI Labs protocol. We're trying to print out the entirety of the module coming up into function to where we can hit buttons, where we can inject packets in order to hit buttons. We need to verify what all the packets are. So I spent $50 fucking on another one of these modules because it blew up the previous one. I spent all that money. So now we need to put a system together by which we can print out all of the packets there. It would be like a 6-paragraph Nightbot command. I can't do that, man. We thought of like publishing a like a quick YouTube video, like a private YouTube video that would explain it, or just clipping the explanation, but I can't get the explanation down to less than a minute. So it's whatever. It's whatever. I just have to explain myself a billion times a second. So this is whether or not it's TX or RX, and if we're clearing the packet after every one that we receive, then we should be okay. We should be able to print out the identity of the packet. I still need to produce a system that's going to make is TX a 1 or a 0. So what we need to do is when we get packet, if serial 2 is available, blah, 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 I guess what we can do is we can get packet and then get packet. We can get packet. Serial 2 is which one? Serial 2 is the one that we've already have connected. So that's going to be RX. This one is get packet TX. We'll have to run that second, though. Oh, we're just going to do this sloppily. And then we do respond packet. It's not really a response, but we'll just run it. We're just doing this in a sloppy way. It's okay. We can be sloppy boys. Like that. Respond to the packet. Bob's your uncle. So get the packet RX is TX is equal to 0. Respond to the packet. Get the packet TX is TX is equal to 1. Respond to the packet. Clear packet should probably be in this loop if we're doing it this way. But I guess we'll just be nice and do it this way. So yeah, that just means that we have our 0 or 1 set up, and we've either on either serial port we've taken a look to see whether or not we get an appropriate packet. And when we do, we put stuff from the input buffer into there. Either direction sends the A's or the 20s, right? I think so. I think so. Yeah, because a 2.0 packet is telling the recipient to do something, set something. An A0 is the recipient, or A0 is telling a response to something. So when we press a button, an A0 packet sends out. Arduino. The Arduino is sort of, it's a little bit of an offshoot of C++. It's sort of C++ with a couple different definitions and stuff to make microcontrollers a little easier, and it's a little less comprehensive as C++, although it's kind of like a wrapper and a wrapper and a wrapper. So we call it C++. Anyway, this is what you use if you want to program stuff on the Arduino, and we're using a TC 3.2, so we have stuff like serial 2 and 3 and 4 and stuff like that. Got all kinds of good stuff. All right, anyway. So, okay, that's that, but that's get packet. We need get packet RX or TX. Serial 2 is the one that's already hooked up. 2 is the one that's already hooked up, and we're moving TX to RX. So then this one is TX. So this one is RX, and the one we're making is TX. So we need another function. So I'll take this and I'll just repeat it. Just make it easy on myself. And this one's TX. This one's serial 3 available, serial 3 read. And then we're punching it all into the same locations because we've already done the RX, and we go over to the TX. And I could put the Boolean inside of there. I'll just keep it here. Doesn't really matter. All right. So now I think Demi's letting his kid enter emotes into chat again, which is always cute. All right, so we've got three serial ports. I really hope, Godspeed TNC 3.2. I hope you can handle it. So we're going down here. We got our TXs and our RXs, and we got all that set up with the Boolean variables so that we print out the right thing. Basically, what we need to do is at the beginning of checking the packet, we need to print out whether or not it's a TX and an RX so that us, the humans, reading the serial output know what's going on. From there, if the ID is nothing, we just go, we break, we don't do anything. So if no packets are sent, we go through our TX and our RX and nothing is happening, and that's fine. That's totally okay. We need to have a 20 or an A0 in order to trigger it to store the packet inside of the buffer. So when we find something that we know about, we're going to print the packet and then clear any subsequent packets. We're not going to send anything back. So we just turn that into a print. And we get rid of the identification of the direction here. Most of this stuff will line up properly, but this is how we faked being the module before, is just by sending the appropriate responses. See, this is where we set discovery equal to 1. We're not doing that. We don't have to worry about that. Command leg app, success. All right, so take that. Do this. This is the exciting part of engineering. Look at us go. Oh my God. It's wild. All right, this one is command legap connect. So we're gonna take that. But now, if we transmit legap connect ID, we need to take that from our definitions above and turn it into its own thing. So we need to take that. Whenever we respond, we need to make a new thing. So from 031A, we got that one just fine. Let's take this, cut it again. We're tricking the rock into thinking. That's what we're doing. Okay, so what case are we looking for? We're looking for connect ID. And I'll get that from the data sheet, or I could just get it from... I do kind of still want it to print out the ID, though. One sec. No, you know what? We don't need... We're going to print the whole packet after it anyway. So we'll just get command legap connect. The lay is LE, as in low energy Bluetooth, but it's just fun to say it as a French accent. So we're not going to worry about any additional transmitting or anything like that. Yep, okay. So all we need to do now is we need to know what that packet looks like. So command legap connect. Yeah, the special cases will have to turn into their own thing. Command legap connect. And that we're going to look that up. Well, I mean, I've got it in the other program, so I'll just go over here. That's all the way up here. And these are these guys. Legat connect. So 3, no, that's the length. 31A. Oh wait, that's already there. Huh? What did I miss? Command gap connect 31A. I guess there's multiple 31As. It's going to be sent and received. It's the Bruce's Gooses emotes. Nice. Event connection is opened. Get rid of the send. Get rid of all this. Do one of these. So we just got to configure this for all the different packets that we get. Where? Oh yeah. Huh, sorry. Wrong window. There you go. So where are we? We are doing connection opened. So that one is a 0800. See, I already know the packet structure, so I'm sorry to go over everybody's heads. Those who have been here kind of know the SI Labs has a particular packet structure, and it starts with a command or response byte, then it has a length byte, then it has like a class byte, and then an actual command byte. Or whatever definition. It's those 2 bytes that we're using in order to define what the different packets are. So 0800 is going to be the connection opened. Yeah. So 0800 in hex. In hex. Procedure completed. Procedure completed. Procedure. Soft timer. Response. Procedure completed. There we go. 9-6. Get read characteristic value. I guess we're going to have to make one for that, just in case we get it. And then get rid of all this. Oops, that was a little too much. 906, and then we print and clear. Or if I should put a blank line below that. You done with all the emotes. Read characteristic value. So that's a command that we get. Read characteristic value. We got to set all these up so that we don't have a lot of unknowns. We'll put everything we know in there. We're not going to implement the full thing, but I just don't want the more we work on this, the easier it's going to be once we run it. So it'll take us a couple minutes. If you guys bear with me, we'll get to the cooler hacking stuff in a minute here. Because like this program, janky as it is almost done. And it can remain janky as long as it just works. So let's see. We get read characteristic value. We just search the whole thing, I guess. Copy, F, paste, find. Nope. Nope. Yes. So 9-7. So take that entire thing, paste it. 9-7. A lot of cutting and pasting today. That should have been X. Control X. I had like a little bit of shrimp salad before streaming. There's a lot of dairy components in shrimp salad, and so I'm borping pretty hard right now. So RSSI, battery, and button packets. The button packet, the battery packet, and the RSSI packet are all the same packet. So let's make a case for that. That's during the normal operation mode. There's one. It's like a particular type of command. So we'll do a multi-line print in order to define exactly what it is. So when we have a button press, the button press is going to look like this. And it's going to be length of B, button, RSSI, and battery all look like that. But it's going to be a 9-4. So we're going to make a 9-4, 0904. And in this case, we don't need any of this stuff. Any of this garbage. It's all garbage. Print and clear. Breach. And then we need a statement. We need to go if, and then input buffer. God, I've been coding this for so long that I just kind of like know where everything is. If the input buffer of position, it would be after the first 4 definition, it would be 0, 1. So it's equal to 1, 1. Input buffer of 1 is equal to 0x11. We should have more variables in this code, but whatever. serial.print, and I guess this would end the line, so we'll just call it battery or whatever. So this one, in this case, oh wait, no, 1 is the wrong. No, that is, yeah, if it's 1 then it is a button. So we'll put space button. We'll do button press. And then we'll have it print out the rest of the packet. So what's going to happen is it'll first do serial print, and it's going to print out whatever the hell that's called, 9.4. We need to find out what 9.4 is called. So we need to go to the data sheet. Oh god, this is so fucking comprehensive. 9.4. So we look for 9. We're going to look for a follow-up 4 on the line below. That's how we've been searching this, because it's so complicated to find all these different packets and their IDs in this SI Labs API datasheet. The search isn't as effective. So highlight, copy, paste, so that I'm looking at the table field of 2 and I'm looking for 9. And so we just fly through them and look for the 4. Luckily, it's easily found. Command GAT discover characteristics by UUID. I think it's an A0 though. I think we're not discovering by UUID. I think we need to look for that top line to be A0. So I'm going to keep clicking through. And obviously, I mean, if we really felt like being crazy, we could program all of these signals into there. That's too much work. Too much work. 9.4. Event GAT characteristic value. So we're just going to print that out. So we know what it is. Characteristic value. If it's 11, it's a button press. If input buffer of 1 is equal to, and this is where we go to my notes on what we observed previously. So if it's 11, it's a button press. If it is a, where do I have that? If it's either 21 or A1, and that gives us either the RSSI or the battery. I think 21 is battery. I think actually 21 is RSSI and the other one is battery. So 21 is RSSI. If it equals to 0x21, serial print line. It should all be print line. This one shouldn't. This one is print line. I'm gonna put the space in there. And then this one is RSSI. That finishes off that line. And then if it's 1A, I could probably make a better way to do this. Whatever. Let's just get this done. 0x1A. Serial print line battery. All right, and we clear and do that. So if that line isn't there, then we've got a third type of packet. Either way, we're going to print the packet afterwards anyway. So if we get an EVT GAT characteristic value, it'll say whether it's battery or RSSI or a button press, and then it'll print the packet out anyway, no matter what. So 01 command lay connection get RSSI. This is a reply, and then get RSSI and then connection RSSI. Like connection RSSI. We can't send it unless we have it defined as something. Why is it not finding it? What? Oh, we're in the wrong code. Oh, and there it is. So that's 8.3. Make that one real quick. Why is that all discombobulated? There we go. 8.3. And that's get RSSI, right? Or is that just regular old? event lay connection RSSI. Clear that out. Clear this out. Wait, that was the wrong one. Wait, which one were we? Oh, God, I'm so confused. Okay, hold on. 8.3 is not get. 8.3, not get. 8.1 is get. And we get rid of the direction. And then we clear. Okay, man, that was confusing. All right, there's that. Man, I hope this works. I think it should. I think it should. All right, so we don't do anything there. Instead, we just do serial print line and then command hardware set software timer. And then we do our due diligence. Really, honestly, we could probably have reduced this and just done the print and clear. Well, the thing is, we need to make sure that we have a packet first. We could have made sure we had a packet in the main loop, and then if we have a packet, we can define where it's coming from and all that stuff. Oh, well, whatever. Who cares? We're retooling code. This is just what happens. Boop. Boop. And then everything else that we don't know ends up down here. And there are some things that we don't know that we're, well, I think I've set everything up that we don't know about. So I think this is ready to go. I think this is ready to go. We've got our giant gauntlet of packet definitions at the bottom. We have our RX and TX systems set up and untested. We know this works for making sort of a, what I'm calling a CLID, which is just a combination of two different routing or whatever things. And then I think that's it. So we're going to get into a mode where it's going to be requesting, basically what happens is a timer expires, and then, oh yeah, we need to have the timer expire thing, whatever that is. The timer expiring is going to look like what? Hardware soft timer, event hardware soft timer, and that's C0. So we'll just set up C0. Usually we'd be sending this, the timer expires, but we need to actually receive timer expires as well, so. Print line, and then it's soft timer, and then we do this stuff. Okay. All right, so that'll, because it'll be soft timer, then it'll request RSSI, then it'll send RSSI, and it'll just do that in a loop. That's the weird way that this module is connecting. You guys who just came in and don't really know what the hell I'm talking about, we've been working with this thing for far too long. This has gone on for too long. This is too much with one project. This is supposed to be a lot simpler. I now can intuit the connection method of this stupid thing. I really hope we discover a couple packets that we've never seen before. But we got to program this. We got to plug it in. We got to get it working. So let's do the pin swap first. What we'll be doing is we'll take the TX2, the output line from serial number 2, and we plug that into the receive line of serial 3. So what I need to do is just hopscotch a couple pins here. Easy peasy lemon squeezy. Take this guy. Just TX2. Hello? Ugh. It's hard to do without tweezers. We'll go up there. Nope, one more. If I did software serial, I could just very easily do this just with reassigning pins, but I didn't do that. We're doing it with the built-in serial stuff. I figure it might actually work better. these have their own individual buffers, these different serials, but then we are transferring the buffer over to our own buffer so that we can then act upon the numbers. Weird way of doing it, but it works, it works. So what I'll do, well, first off, I should probably disconnect this thing from everything else. I guess if I just turn off the base, it'll be fine. We don't want to accidentally make weird stuff happen over here and have it affect our programming. So plug this guy in right here. Boop. And then we didn't set up any blinking lights on this thing, but what I can do now is just go over to my sniffer code, tools, board, teensy, serial, 96, blah, 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 I don't care. COM10, teensy 3.2, that's correct. And then basically what I need to do is just upload my coad. There we go. Let's see any semicolons that I forgot to put in at the end of lines. We have a wiener. Duplicate case value. Oh, I got a couple of those. Command leak, set parameters. Oh. Well, let's find connection opened. Yeah, it looks like we were a little sloppy with this, so. Well, it's nice of it to check that. Otherwise, we get kind of a weird response, and we wouldn't really be able to figure that out. Connection opened. 8-0. Yeah, it's looking like an 8-0. I don't think we're getting around that. So the depreciated one. Connection opened. Where'd the other one go? We got 2 9-6s that we need to deal with too. Connection parameters. Also 8-0. Which one was it? Do we remember? Because the other one sets all this stuff. And it's got all this information. I think the one that made sense was the depreciated one. So this one is not actually the undepreciated one. Underappreciated is what it is. This one is invalid. We commented out. Oh, one is the response and the other is a command. Depreciate is a command, and the other one is not depreciated. I don't have anything to figure out. Well, okay, here's the deal. Oops. No, uncomment it, you bastard. We could just put an if. What did I call the variable again? Packet TY? Yeah, packet type. So which one is the depreciated is 20. Do this. I mean, I don't know. I'll just use another if statement. I don't know. It's sloppy, but is it 0A? Hold on. Because the other one is 0800. Where'd I put that other one? Okay, 0800. Do this one. I think I have them backwards. I do. Yeah, it's whatever. Nope. I'll fix it. I'll fix it. Okay. The other one is 0A. 0A or A0. I need to just look anything up. Hold on. A0, yeah. Okay, there. So if it's an A0, connection opened. If it's a 0, if it's 20, then it's the other one. There's not typically overlap. The other one I need to look up are these repeats right here, 906s. Read characteristic value is what? Oops. Value by UUID is 20. 69. Get characteristic value from offset. Get characteristic value 2397. That needs to be a 7. Okay. Procedure completed. 0A96. And the other one is just an example. Okay. Oh, I'm beeping. Glucose level is approaching normal. All right. Hopefully that'll pan out. Okay. I think that does it for the repeat values, I hope. 94. Yeah, let's try again. Upload. Oh my god. Oh. Lowercase y. Did I not give it an input buffer location? No, that's correct. We're looking at individual locations on, so the input buffer is an array of bytes, and we're looking at the location of that array and comparing it to the hexadecimal value, what defines whether or not it's a button press or a RSSI value, or so the when the Scandinavians program this module, they're using a event structure in order to put their own thing in there. And so what they did is they set one of the bytes as the characteristic value of that event, which defines what information is getting communicated out of that packet. Let's try it. Boop. Beep, bop, bop, bonk. Duplicate case. How do I have multiple C's? What's happening? Hardware soft timer C0. Oh. Set soft timer. So does this one also need... This one needs a 20 or a 0A. And we'll need to figure out which one is which. Oops, not X. No. Copy. Copy that. Put that down here. So we need to see which one is command hardware set soft timer. Set is the 20. Then the other one is just soft timer event because it's a response. Of course, yes. So when I read the packet, I'm not showing you guys everything right now. When we receive a packet, we set up those 4 variables, the command and the everything. It's all in there. It's all done. See, we just pump it into there. So my stuff variable is the very first byte read. And if it's a 20 or 0A, we set it up in here. But we only do that if it's a 20 or a 0A. So we look in the buffer and we look to see if we get a 20 or a 0A. For the most part, this has been successful in actually finding our information. This has been pretty successful in finding all of our packets. So as far as I know, this works. Are you saying I forgot a double equal sign or something? Geez, you got a weird way of saying that. You guys are hard to tolerate sometimes. Jesus Christ. All right. Probably would have found that. I mean, you guys can't just let me bump into the bumpers a little bit here. Just don't do that. Just let me find it. Because nobody, you know, in programming and stuff like that, you don't get to see somebody get these errors and work through them until it uploads. You gotta let that happen a little bit. I mean, I know you guys are smart. You don't need to prove it to me. We will get through this, you know? That's part of the show that you're taking away from the people who don't see this. And then they get a bad impression of how programming works. My IDEs chat sometimes, and their errors are obnoxious. So, all right, we uploaded our code. We're ready to go. We should just get a serials sharded out of the COM port. Oh, we didn't even build that in. Hold on. At the end of our setup, print line. We started serial. You gotta let me bump into the bumpers, all right? How will people know to like me if I don't show off my enormous... No. Nope. There. So we're ready to receive stuff. Here we go. So I turn on the module. Do we have power running to the... Yeah, we do. Turn on the module. Then I'll turn on the bumpers on this thing. That should connect. Oh, we got a lot of stuff coming out. Got a lot of stuff we don't know already. And it just stopped. Receive, reset, transmit, I don't know. That's a big one. What the fuck? Yeah, something got stuck. So we're not reading properly. I mean, we can read in on one at a time. I can just activate one or the other. But it seems like something is broken. Let's see. Hold on. What's going on over here? Yeah, so we should be... This should be pooping out packets as we go. We're not looking at... We're not seeing our packets come in properly. Now, this had no problems running with just one channel. So our implementation of 2 channels is probably what's affecting it. So 1150-200, base to module, module to base, all that stuff is connected. Serial 2, serial 3, assuming we got the right one. I mean, we did get an RX and TX, but for some reason at the end of this, it just fails. Serial 2 available, stuff, serial 2 read, blah, 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 blah. I mean, I guess I could connect the 2 serials to one pin. I don't like doing that. Or we could observe one at a time and just see what the responses are leading up to the start of the module. Either way, that's going to be a little bit confusing. And somewhere there's a blank print line that's making it into our code. Well, let's read serial 2 first, and we'll punch that into just a big document. Yeah, serial 2 first. So this is normal operation. The get RSSI is being received. If I push a button, well, we're looking at the other direction, so we actually don't see the button press. So all we see is the command that comes back from the base station saying get RSSI. Unless we're connected wrong. Maybe we're connected wrong. No, we're connected right. That, and then skip, and then the one above it, right? Let's see here. So I moved this one, so we are 4 pins up. 1, 2, 3, 4, yeah. And then 5, and then 6. Yeah, we're on the right pin for serial 3. But yeah, right now we are just receiving get RSSI. So let's turn this off. Pew. Clear the output. And then before that thing shuts off again, I'm going to turn this back on. I'm going to turn off auto scroll as well. So here's all the configurations that are coming through that we know. Here's the don't know. And then I'll push a button a couple times, and then I'll go Control A, copy. All right, that's our first thing. Notepad++. We'll do a new document. Save that. Can I not save it? Fine. Take all this. Oh god, all the split lines are really annoying. Ah, whatever. We can make notes in the margins, I guess. Save that as in the Mercwheel, just there. We're gonna do serial reader. Yeah, and then I'll do a new one again. And now we go and we deactivate serial 2 in favor of serial 3. Turn this thing off. Upload. Hopefully this thing doesn't lose connection, because otherwise that's going to make our job a little weirder. Start up the serial. Turn it on. Turn off auto scroll. Wait until this thing goes up. Nothing? Are we getting buttons? Yeah, we are. Okay, so what happened here? Serial 3 didn't do anything. It did not work. Oh, because we didn't initialize it. Wait. No. Serial 3 available, serial 3 read. Serial 2 read byte. Ah ha 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 ha. And that's where the backseat coding would have robbed you guys of that little bit of troubleshooting. That might mean that I'm able to implement the original full code. Let's go back and try the original full code. Full code, full code, full code, full code, upload. We can just see what's going on the serial right now. Beep, boop, bop. Yeah, see, it's sending and receiving. Software timer, get RSSI, get RSSI, connection RSSI, soft timer RSSI. There it is. Okay, so we can turn this off, clear output, turn it back on, get it all the way to the point where buttons are pressing, and I pressed a couple buttons. Then I quickly Control-Alt-Copy. I'll take another one there. That's going to be a very big document. And then we'll turn this all off. I don't need this anymore. Turn it all off. I can turn it on again if I need it. No, that wasn't a typo. That was just I forgot to reassign the stuff. Man, these are some weird big packets. What are these? How much did I capture? Oh, not a lot. What the fuck? I didn't get very much. Okay, we're gonna do it again, I guess. I need to get rid of these interim lines. I don't know what does that. Well, we can just deal with it the way it is. That's just the way it is, yeah. Well, no, it's not. We see all the packets running by. I think the serial buffer display or whatever, the display of all the packets isn't keeping up. So maybe I need to auto scroll and then Control A copy. Oops. Oh, board's not available. Right. Plug it in again. Open up this thing. Serial sharded. I hit reset. Yeah, there it is. Okay, and then I turn the unit on. Yeah, it just like stops logging after a certain amount of time. See how it just stopped right there? I think maybe we need to isolate TX and RX. Oh, whoops. Ah! I pasted over all of my code. Well, this one we got a lot of stuff. Boot, reset, boot, bondable mode. We already know how to respond to all that stuff. Soft timer, end procedure, set soft timer, hardware set soft timer, set connection parameters, okay? That was the second timer that gets set. And then start discovery. And then this weird unknown packet. I think we already know what 1C is the length, and then it's an 0300. Let's just check up on that. So we're looking for an 03 and a 00. And it's an A0. Those are 20s. Oh. Oh, scan response. Okay. So let's set that one up so that we have it in our sniffer. .300 event le gap response. So that contains the UUID of the what do you call it? The Bluetooth module that we're connecting to. It's just part of the whole ensemble. Upload that. Like, can I cook or can't I? You know? We're getting there. We're almost there. Ah, what is going on? Scan response is all we're getting out of this thing. Can I... There, I just stopped it by hitting both shoulder buttons. So we're not getting the typical operation stuff. I don't know how that's coming into the module, but we're not seeing our button presses or anything. They're not being recognized by my code. They might be coming in too quickly, maybe. But if we're not receiving those, then that's trouble. We should be seeing like the EVT button packet coming in from somewhere, and we're not. I don't know why. TX. We're not seeing any RX. RX isn't working right now. So what's up with RX? serial 2, serial 2, serial 2, serial 2. Comes up, reads it, is TX 0, then responds. But for some reason, we're not seeing anything coming in on it. And this is the original hookup. This is the hookup. And it is definitely in pin 4 of the microcontroller, which is the RX of serial 2. Maybe serial 2 and serial 3 just don't like to be activated at the same time. It's weird because I thought we were seeing RXs in this. No, we're not. No, there's a couple. We were seeing RXs and TXs. So I'm getting a little discombobulated. Where's my... Oh, I turned off the serial monitor. Huh? There we go. There's our TXs and RXs. Oh, and there are the button presses. See that? When I push the button, those packets fly by. I mean, this is all stuff we already know how this operates, right? So I show you guys up here, button press 0, button press 0. So this is the button being pressed, and this is it being let go. That's it. That's all there is to it. We don't have any other unknown packets. See, what I want to do is I want to observe the entire beginning part so that we can observe whether or not there's a packet that we don't know about coming in here. But right now, hey, look at that. We got all the functionality we'd ever want or need. That's where we want to be. This is where we want to be in the operation of the device. So we've got it set a timer on the module that is expiring, and when that timer expires, then it's asking for an RSSI and responding to the RSSI request. That's it. That's just what keeps it awake. But when we send it these packets representing a button press, we're not getting a button press. What does this packet look like? I just want to look at one of the button press packets. Where's it going? Oh, God, there's so many. All right. 94111 1B, blah, 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 blah. Yeah, that's a button press. I mean, man, that couldn't be more clear. That's exactly what we send. It just doesn't like it when we do it. So let's take a look. Let's clear the output. I'm going to, well, turn off the device, clear the output. I'm going to reset the Arduino. Turn it on. Let it come up. It stopped reading at a certain point. And that's the problem, is that it's setting a timer and then stops reading. I don't understand why it does that. Ugh, and then we miss what we're looking for. All right, so what we got from the previous read where it stopped, and I don't know why it's stopping. Where does this one stop? Yeah, it stops at the same part. EVT hardware soft timer. Why is it doing that? Why is it stopping there? EVT hardware soft timer, same timer expiring, and then it just doesn't do anything. Even though the module, like the rest of the thing, is coming up. I think maybe that's where the Arduino runs out of stuff. What the fuck? That shouldn't happen. This thing should spit out a packet if it, I guess if the packet was 00. Yeah, there's always going to be some weirdness on the line. I mean, it's always going to get weirdness. It's just something is triggering the command to be an unknown value. But then if it's an I to know, literally the next line is for it to print what it is. So it transmits, says, I don't know, and then it should give us a value. Why isn't it giving us a value? What is that about? That's a weird thing. That shouldn't happen. Because we get all the way down here, and we scan our packet, and then we get to, I don't know, and serial print line, I don't know. Then we do print packet, and then we clear. When we do print packet, we're printing out bytes, and we're telling it specifically that we would like it to print out all of the bytes, even if they're zeros. So we should definitely get a line right there. So it's just something's just weird and messed up. That's really weird. All right, well, let's try to get let's try to get past that. Strange results. So turn it off. Reset the sniffer. Open this up. Serial's ready to go. Turn it on. Auto scrolls on. We just let it go. I'm gonna hit a bunch of buttons. See, it just stops right there. It just stops. Oh my god, that is annoying. Huh. Yeah, the microcontroller just stops. What the fuck is going on there? All right. Why does it stop? Okay, am I doing something that kills Serial at that point? When it gets timer. Well, where'd that go? Set soft timer. Print packet, clear packet, break. Print packet, clear packet, break is what we've been doing this whole time. If packet TY is equal to 20 or 0A, we do either of those. But somehow that just like... Yeah, I mean, the unit has been... I can actually... Oh, yeah, here we go. I can see on the oscilloscope that it's still sending signals. You guys weren't able to see that, but like all the stuff that's supposed to be sent, you can see the yellow right there. If I push a button, you can see the button gets pressed. That packet is running into there. So everything is still functioning. It's our microcontroller that's all messed up. And our microcontroller is just getting 5 volts from the computer. So it should be okay. It should be all right, I guess. There's nothing real dramatic going on the serial lines. Why would it explode right here? Why would you do this? What is the purpose? 2-0 or 2-0 and A0. 121 1A. That all works too. 2-0 A0 on that one. I don't see any reason why this would be breaking everything. If serial. I don't know. It's like just like a buffer issue or... It's getting to print packet and then it doesn't print the packet. Print line, print packet. Print packet doesn't do anything too dramatic either. Print packet just boop, 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 boop. Print packet. If we're a 20 or an A0. And it's doing this before clearing it, so this should all be populated. What happens after the case statement? Nada. It just default break, default break. Do we forget a semicolon and a break somewhere? No. Looks like we haven't. Where's my timer? Colon, parentheses, semicolon, 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 print then clear. Print then clear. And these are just break. Break. Huh. I mean, print clear would probably be something that I could do at the end of this, but I haven't posted this code, this specific sniffer code. This isn't all that complicated either. This is literally just the same switch case statement that I posted a while ago. Just with a couple tweaks here and there. Like, it's not supposed to send anything. But like, I don't know why it's breaking. Do I need to like jiggle the cable and make the serial restart? Oh, so what if I deactivate one of the serials here? I'll just deactivate one or the other. So let's deactivate serial 3. Because basically we're running our 2 serial getters back and forth. Try posting a serial debug right before your case, before the switch, just to see if the outer loop is still running. The outer loop is just a back and forth. That's the weird part. I just don't know, I don't know. Because it's constantly running. So what happens if... Well, okay, I'm just going to deactivate one or the other, and we'll just look through TX logs and RX logs separately for a moment. Because what I'm trying to do is find out what's happening right after we get to the known parts and see what that final bit of configuration is. There might be either a packet coming from the base station, or there might be a unique packet that's sent from the receiver, so we can observe that separately, I think, and see if we can get a good readout on it. It stopped. It may not be a bad cable because it stopped at the exact same place both times. So it might have to do with the Arduino buffer or something. The way the serial's being represented, which I guess I could open the serial port on PuTTY and take a look at that too. But I'll just try this first. We're gonna disable serial 3. Let's upload that. Power down. Open up this thing. Clear. Turn it on. Let it come all the way up, and then we'll cut paste that into a box. That's stopped here too. What the hell? It only got up to command hardware set soft timer. Well, I'm going to take that, and then we'll try the other one. And then we're probably back to figuring out what's up with the COM port. So this will be the RX, or sorry, the TX. So we'll do that. I'm going to label this one. This one will be serial 2. And so we'll take serial 2. I'm going to... Oh, wait, no, that one was serial 2. No, wait, which one was that? Oh, I'd forget. Which one do we have? Yeah, it's that was serial 2. Serial 2. Now we're on serial 3. Serial 2 deactivate. So we want to enable this one. Disable this one. Skip the print packet for the timer command? I don't know. Maybe, but hold on. Upload. I was gonna throw a fit because I didn't disable the whole thing. No, I guess it's okay with the misdefinition of the functions. Serial, and then this is it looking for a device. So if I hit one of the buttons, or if I hit both shoulders at the same time to wake this thing up. Hello? Did I hold them down? Yeah, there we go. I want to take a look at that, actually. That was a module connect, so we can take that from our TX. We can look at where the junk data is coming in. So we got a bunch of I don't know packets, which is it scanning all the individual devices, but we've got a couple extra ones in here, too. There's the button presses. There were a couple I don't knows in there, and then this one is a little weird too. But it looks like the TX isn't getting caught up on the timer. All right, let's close that so we don't just make a shit ton of data, but... Huh. Is there no end line on that? Or is the serial just getting a little... I think maybe the serial's just having trouble. Nope, that's not a print line. Dun dun dun, LN. Although it might be more compact if I get rid of the print lines, to be honest. If I have it print a packet and then do an end line, that would probably be a little cleaner. Because then it would just be, well, no, but those titles are different lengths, so it's easier to interpret this way. 8.2. That's one we don't know, I think. Let's see what 8.2 is. So 08, and we're looking for 2, and that is a A0. It's a response. Get read characteristic value, and then we have a response. Well, no, that's, yeah, read the characteristic value, and then we're coming back with that. I think we know that one already, don't we? Huh. Command lay connect. Well, that's a command, so that's not what we're doing. I think we've already, we may have already uncovered our $50 packet. That's one. EVTLA connection parameters, we know that one. So let's add that in. So we need 0802. We'll just put it right here. Seems like a good spot. EVT lay connection parameters. Low energy connection parameters. Connection handle, interval, latency. Yeah, we already know this one. I think we already dealt with this one. I just don't know why it's being sent so frequently in the middle of our readout. All right. Oh, we're in bondable mode. Okay, yeah. So serial started. Which one is the one that we're looking at? We're looking at this one. Get characteristic value. Get procedure completed. And then we get a 9.9. So what are we? We're responding to something with a 9.9. So what is 9.9? This is just how we're going to figure out all the stuff that it says. 9.9 was a response, right? No, that was a command. What are we telling him to do? This might be the signal. This might 9.9 might be what we need to send in order to get it into button press mode. 9.9.9.9.9. 9.13. 9B. Come on. 9.8. 9.12. 9E. 9.11. And we're not sending a 9.11. 9D. 9.5. 9.0. 9.9. Command get write characteristic value. What? When the value of a characteristic in a remote GAT database, if the given value does not fit one at the PDO, write long. This is not English. I don't know what this is saying. GAT procedures used automatically. Received GAT procedure completed event indicates that all data is written successfully or that an error response was received. So 9.9, huh? Length is 2. It's 0.0, so it's a success. And it's something that we say after procedure completed. What the? Okay, 29900. So 99. Do we already do something with this? Write characteristic value. I think we do. I think we already do something with this. We don't. Okay. This might be the key. So something is trying to write a 9.9 characteristic value. So it's trying to write a characteristic value, and we're saying success. That's what we're sending back to the base station. Saying, yeah, you got it. We did it. Might be one of the ones that just slipped through the cracks. I don't know. So we'll do that, and this is write characteristic value. Yeah, this is going to take a little bit for us to work with this and get it functioning. I'm just going to keep something that the line that says new on it. It's weird that we are doing the response and it's still 229900. So that would be 99, and they would give the connection a handle and a characteristic handle. Values normally received from get characteristic event, characteristic value. Somewhere in that other printout, we probably have this. Yeah, right through the $52 crack. That's an expensive crack. Let me put this all the way to the front. We're still looking. I mean, we're still hunting around for stuff that we haven't seen before. Like an 8.2. I think we know 8.2 though. Which direction is that? That's an A0, so that's a response. Yeah, low energy connection print. Wait, we know what that is. Hold on. Did something break? Eight-2. Why is there shit breaking? Wait a minute. Why is there shit breaking? This doesn't make any sense. It's right here. What do you mean you don't know? You know exactly what it is. What the hell? Wait a minute. It doesn't make any sense. You know exactly what it is. It's right there. Case 0802. 0802. Are these little endianed? I don't think so. I don't think it's a 2.8. I don't think that connection exists. No, these aren't. Yeah, these aren't little endian. They're individual values. What the? Wait. Oh, did I just add that? Okay, all right. So that's the one we just added again. I'm starting to lose my mind. We got 9.9. So that's one that we've been missing maybe this whole time. Where are we in the grand scheme of things? Wow, we are not far along. Let's go all the way back and let's start from the so here's all the garbage, these giant packets, and what that is it's looking for Bluetooth IDs that it can connect with. So if you guys were wondering what Bluetooth ID my phone is, or maybe the speaker that I have in here, or some other thing, there you go. You guys got my Bluetooth addresses. Now you'd have to find my house in order to do it. What in the 9.9? I thought I changed that. You guys gotta stop backseating me so hard, please. Yeah, that is 9.9. It would have barked at me for that in the compiler. Scan response, and then we get these dunno packets that are, I guess the CL ID is in there, but for some reason it doesn't print them. Which doesn't make any sense because we've got exactly, oh, you know what it is? The packet doesn't have a header of 0A or 20. It's just garbage. It's just garbage data that's coming from this command. So when it's looking for a scan response, it's doing a lot of other stuff. There's all kinds of weird serial coming in. And so when that happens, we go into the switch case, but it's an I don't know because it still has a positive ID. But then it goes into the packet reader that doesn't read it because it doesn't have what do you call it? It doesn't have a 0A or a 20 at the beginning. It's just some other character. I don't know. I was told that Bluetooth Low Energy requires a location, but none of this stuff does. So gap scan response, gap scan response, gap scan, blah, 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 blah. Until finally, I hit both of those shoulder buttons and hold them down. Bop, 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 bop. Gap scan response, blah, 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 blah. Keep going, keep going. See, the printer doesn't print unless it starts with an A0, which is fine. That's just cleaning up a little bit of the data for us. We could probably get it to not even print stuff if there's no A0 or whatever, but it doesn't matter. It doesn't matter. We're just here to quickly get data. Oh my God, these packets, they don't stop. It just continually scans this stuff. Oh my God. Please. Please to be doing something else. We know there's other data in here. We'll get it. As soon as the module comes up. Oh my God, I feel like I was doing the same thing over and over again. Up. Command Legap connect. Ta-da! Module number 1. Come on down. Connection opened. So scan response. This is now the ID of the Bluetooth module, which would be 86B D7 43 C9 7A. And if we look at it close up, those is the same numbers. Where is that? Wait, where's the address on this thing? I thought there was a printed address on the thing. Oh, it's out of focus. It'll help if I focus it. I think it's the FCC ID. Well, the other one had it all written on the front. 86B. Where is that? Q. Blah, blah, blah. Yeah, I don't know. I don't see it. It was written on the other module. It was pretty funny. Oh, well. Whatever. I guess they stopped printing the IDs on them. Unless it's the 22. Q0. Is it a Q0? Or maybe 00? No, we can only move out from here. Hold on. Oh, it looks like a Q. No, 0008 CM. That's not the right ID. Where the hell is this ID? MSIP? No. I guess they didn't write the address on this one. The other one had it. Here's a can from the other one. Wasn't there an address like right on the outside of this thing? Yeah. Oh, maybe not. Maybe I'm wrong. Maybe I'm wrong. BGM 111 model there. FCC ID is not the same. I see BGM 111. Huh, I could have sworn there was an address on this thing. Guess not. Oh well. I thought we'd be able to equate the same thing. But I guess not. Anyway, that's this is the Bluetooth ID. It's just Endian flipped. What is the QR code? I don't know. I'm not gonna look it up right now. I'm busy. You look it up. Rewind the VOD and look it up on your own. Probably brings you to Scilabs or something like that. Connection opened. Here's one we don't know. It's an 8.2. Did we just add 8.2? I think we did. Oops. 8.2. Yeah, we just looked at that. Event lay connection parameters. We know that's valid. We already respond to that in our code. We just didn't code it before. Back to Notepad. There you go. Connection close. End procedure. Probably should save this. So it does do the depreciated set parameters. And here we're affirming that the parameters have been set. And then we get a button press. Button press. There's the 8.2. 3.9. Or sorry, 9.0. Okay, this one is new. Because we get button presses before. We got those button presses, but I'm pretty sure we responded to those button presses. What the hell's happening? This one is length of 3, and the data, the packet is 1F70, or 0F71. And it's a 9.0. So what is 900? And this is an A0 900. Double aught. 9.1, 9.6, 9.0. Event GAT MTU exchange procedure completed. Aha. Ah fucking ha. That is the $50 packet. So before we receive the event, we have to say that the MTU procedure is completed. Otherwise, the packets don't go through. I think that's it. I think that's the command. I think that's the command, chat. I think we figured it out. We know what 9.9 is. But this is something... It's a response, though. I guess maybe we need to send this out. Use the scope command. I'll do it. I think that's it. I think that's what we need. So let's put a new one in here, too. I don't know if getting this answer was worth $50, but so 9.0, and then this one is get MTU exchanged. I think this might have been the $50 packet. What's up, Woody Basket? How you doing? That guy is a very Woody Basket. This might have been the $50 packet. I hate that I had to spend $50 in order to learn what this thing is. $50 is like half of a pizza, right? That's like half of a pizza if you get it delivered on DoorDash or whatever. All of my pizzas come in halves. I mean, they could, like, I get half a pizza. I don't know what that, I don't know. Maybe it's not, maybe it's just me. All right, so what is it saying here? I'm just going to put in the notes what it is. But we're going to look up all these different values because we should know what these all are. Waiting on dinner. Ah! 9 p.m. You're in England. Back over to here. So it's what is our data load here? Connection handle and then the exchange ATT MTU. What the hell is that? The connection handle should be 1. We can confirm by what we've received that it is in fact the 1th module to get connected. Those will, I guess, become 2s, so. Toronto didn't eat the entire day, so it's dinner now. Oh, okay, that makes sense. That does actually make, that tracks. I had shrimp salad and it completely fucked up my glucose levels and I'm angry at it now. Fuck you, shrimp salad. I need more insulin. More insulin. I need more insulin. Why was there so much sugar? I guess the buttermilk or whatever they used to make the shrimp salad did it. What a shitty lunch. I need liquids. I need to flush my kidneys. Hold on. I'm just gonna get seltzer. I got a can of seltzer over here. TV static. That's what that is. TV static in liquid form. Corn syrup and everything. It's from like a fish place. So it shouldn't be. I guess it's got to be buttermilk. I don't think they're adding corn syrup to everything. I wonder what this oh bother guy's doing today. And I'm like, my kidneys. Welcome to my text stream. Liquids. Okay, so exchange to ATT MTU for some reason, and we're just gonna fake this, is F70. Well, it's 0 F7 because you actually flip these. So it's F7. What does it even mean? But the connection handle is 1. So if we register another device, we will do the... Wait, which one is TX? We're receiving this from the base station, I think. Yeah, it's well... I'm always thinking about actually registering a second module while we do this. Yeah, Bluetooth API for Scilabs is Blue Gecko module, because we're trying to fake being a Bluetooth receiver module, transceiver, I guess, but Bluetooth receiver module from a wireless wheel. And this is the second one that I bought. The other one that I bought, unfortunately, blew up. Because I blew it up. Because I gave it too many volts, it exploded, and I had to spend another $50 on another one. So packet TX is what we are right now. That would be serial 3. That's the one that I flipped over. So this is something that we have to communicate to the base station. Aha! So that makes sense. So this is us closing up the serial. So from there, we do the 9.9. We already know that. GATT procedure completed. So this is before GATT procedure completed? Characteristic button, GATT procedure completed, read characteristic value. 9.9. Man, it's doing this a lot. It's got a lot of repeat stuff going on. This is cursed shit. You know. 9.7, 8.2 we already figured out. We already know what 8.2 is. Procedure completed. 9.9 we now know. So we need to implement that. It keeps doing procedure completed characteristic value over and over again. I don't know what we did is I had the module running, and then I pushed the button to get it to start up. But yeah, it seems to be going through characteristic value and procedure completed over and over and over again. Then button press. 9.5. That's a new one. All right, 9.5. Let's see what 9.5 is. I've been watching Roboz's Stormworks streams, and he managed to convince me to buy Stormworks. He messaged me like, it's either 6 months ago, it's like 2 years, everything's a blur, but saying that he'd love to see what kind of stuff I would make in Stormworks, but like, this is what I'm up to right now. This is worse than Stormworks. It's pretty much on the same level, it's just that I don't get a nice three-dimensional game interface in order to put this stuff together. This feels a lot like, you know, Stormworks or any of that style of games. So 9.5, and it's a 20 signal. Oh, hello. Get descriptor value. But it needs to be, we need to look up the 20 version of it. 9.0. That was it. I passed it. 9.5. I wish my logic analyzer came with a VR headset. Yeah, right? Beat Saber your way through a serial protocol. 9.5. Set characteristic notification. Ah, hello. Oh, wait a minute. That's it. This is the $50 signal. I know I said that before, but this is actually the $50 signal. This is it. This is, okay, one thing that I wasn't clear on with this system is how do it know? Why do? This thing right here is sending just this random serial packet back to the base station, right? The packet's just like up here out of nowhere and gets sent to the base station. The base station goes, oh yeah, that's cool. But it never tells it to do that. And so I was wondering about that. The signal that we just found, the packet that we just found, is the base station saying, set up this notification and I'll respond to it. I think that's the direction we're talking about. That, or it's the module saying, hey, I'm gonna go ahead and need for this thing to be a thing. I think that's what's happening. I think this is where it sets up that it can press buttons and it'll work. Because yeah, here's a button press up here, but then it goes, hey, I need to set this characteristic notification. This is on serial 2, which means that we're receiving it from the base station. No, it's on serial 3. So yeah, we need to send this, I think. Yeah, I think that's what it's doing. I think it's saying I can press buttons. And I don't give no fucks. The packet TX is the one that I moved. And the one that I moved to an RX, which it was originally a transmit. So this would be us talking to the base station. Yeah, so we as a module need to tell it that we're going to be sending it stuff. Haha! I am the wiener! And then that would be... Let me just steal this. It's windy outside. It's heckin' windy. I'm hearing the fence squeak. Sounds like this module's been pushing all your buttons from the start. Woof, Robolathe. That's whew. That one's a dooz. That's a doozy. That's a Duesenberg. 9.5 is something that we're going to need to send. It looks like we're gonna probably get through the reading of the new packets today, and then on Thursday we'll be able to send packets. And maybe that means that if we can free this up, if we can get our program all together, then I might be gaming by Saturday, but I'm not sure. It might be a thing where I need like a day break in order to do all of the boring shuffling of code together. It's like shuffling 2 packs of cards together, basically, and they both still have their function. But you got to be careful when you're pouring the wine to make sure that... Anyway, but no, yeah, this is like two different programs that I'm going to have to mesh together. They'll mesh together pretty well, but I need to get on Thursday, I need to get to the point where we can virtually press buttons. So we're getting close. I think this one might be it. Anything that I'm labeling with a dollar value will, of course, be something that I need to focus in on and implement and test. 9.5 again. Yeah, so this follows... Follow procedure completed. What about the 9.9 or 9.0? Jeez, sorry guys, my stomach decides what happens when. Wait, was it 9.0 or 9.9? Oh yeah, that was right characteristic value. Huh. What the fuck is going on? Wait a minute. Read characteristic value. When are these commands coming in? We'll have to run the scanner again and see what it says, because it seems to be fluttering between stuff. All right, but let's be on the lookout for new stuff. So anything that says I don't know. See, here's where it sets a soft timer Or no, that's unsetting a soft timer. That's clearing a soft timer. And then get RSSI. Here's the RSSI. So, okay, this is the response from the timer that was set. So it set a timer, and then it responds, and that prompts the base station to ask what the RSSI is. So then it says, yeah, here's the thing, here's the event, I guess. I don't know why we're getting that and then that. I don't know why get RSSI is being sent on that line. That's weird. Characteristic value, button press, battery, depreciated parameters. I don't know why that's coming out in the middle of nowhere. So we're in normal operation mode. 8.2. Did we know what 8.2? We know what 8.2 was. We programmed that in, right? That's one of these. 849990958182. Yeah, event lay connection parameters. Just for some reason, it's not picking up on it here. I don't know why. I don't know why this isn't defining. Because it's right here. That doesn't make any sense. I don't know why it wouldn't find that. This program just sometimes just breaks, I guess. Yeah, it's just right here. It's 0x82. This is 8.2. 0A, 8.2. And there's the length, 0A. So A is 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Button press, soft timer, RSSI, value button press. Yeah, okay, all right. So there's we found 3 signals that we either didn't know about. Oh, 8.2 was added. Yeah, I keep forgetting, man. I keep forgetting. We're not in love anymore. I keep forgetting. Things will never be the same again. Okay, so I think we're set up in order to implement the new packets. I think we've pretty much characterized what a module connecting looks like. Now, we've gotten it to the point where it sets that soft timer at the very end of things. And so I think the thing that we're missing is either MTU exchanged or, more likely, set characteristic notification. Because every time we send a button press packet, that's defined as a set characteristic event. If we have a characteristic notification, that'll trigger a characteristic event. Here's the deal. I'm going to end on a cliffhanger. We're going to save this. I guess I'll put all this stuff into the other one. Is this 2 or 3? I keep forgetting. We're not in love anymore. Okay, which one is this? This one is... Scroll, scroll, scroll. So much scrolling. I don't know why. Running 2 serial ports is apparently hobbling my program for some reason. I don't know what it is. It's just shit just happens. I don't know. This one's serial 3. Oops. We want notepad. Serial 3. Bop, bop. Paste all that. Save it. All right, so I've got the record of what we've scanned, and we can update and rescan if we need to. Oh god, this is a tough document to go through. Because, like, it starts in just Garbageville and then connects. But then somewhere, oh man, what a... RX, RX, RX. And then it just stops when it sets a soft timer. We don't have any I don't know commands coming out of RX. So... I don't know if it has something to do with running 3 serial ports at once. Like, just everything crashes. But it stopped at the same location every time when I'm trying to run both serials. So instead of running both serials, I'm just running one at a time. And we've discovered a couple new signals, and it's a signal that we haven't sent to the base, that we haven't seen before. It's a shame we didn't know what to send previously. It's a shame, but we would not have been able to figure that out. I would have been able to get the parameters, like maybe we could identify the packet, but then I wouldn't know what to send in those values. Why F7? Why are we sending F7 in there? Because it's the wait a minute. Yeah, get set characteristic notification. Okay, so it just sent 920. We don't really know. Sorry, 95. See, it's just sending zeros afterwards. So that's a result code, which means, oh, the other line is sending something over to us that will set up that characteristic value. Oh, we need to do another scan then. We need to do an RX scan. All right, let's set it up. I want to figure out what that command... Wait, but we're sending it as a 20. But, okay, oh, it's a stock, it's a canned response. Okay, all right. Hang on a minute. Because we would have gotten that anyway, and if we didn't know what it was, we do like the yes dear signal. We just kind of like send back a, yeah, of course I got that. So maybe this doesn't make as much sense as I thought it would. We're going to try to implement some of these codes that we've discovered and see if anything happens. Because it's not a command that we're sending back. Huh. Because this is the thing that gets sent. This packet gets sent to us, and then we respond with the, yeah, we got it, everything's fine. 9.5, huh? We don't have a 9.5 in the RX because we don't have enough RX capture. Let's try to do an RX capture then. Actually, what we could do is just, I could just receive and I could just flip the wires. No, I'll do it properly. Which one are we doing? We're receiving that one, right? Yeah, all right. God, TX and RX is the most cursed nomenclature ever. I hate it. Okay, let's put that up in there. Indoor micro that I still haven't unplugged. And this thing is all functioning already, so all I'll have to do is just, let's see, it hasn't gone to sleep yet. Yeah, see, there's the get RSSI command. We just get over and over again. So if I turn this off and on again, we should get, like, the typical puke of, commands. Pretty good. Copy. All right, we got much more capture there, so we've got much more data now. So I'll just take all these RXs. I'm just going to do one of these. We're going to need that because this is going to be a very long document. A very long document indeed. With a lot of garbage in it. All right, so now we got a good RX capture. Let's see if there's anything in here we don't understand. So, gap scan response is a Bluetooth thing. Scan response, event leg app. Wait, those should say RX. Huh? Wait a minute. Did I accidentally... I did the wrong one. Shit. Hold on a minute. I activated the wrong one. I gotta find my big equal sign. Unless, did I not? No, I pasted it. There you go. I did the wrong direction. Let's undo this. Pop. Okay, let's get an RX capture. Wait, why did it print them all as the wrong... Hold on. Hold on, I gotta look at my code. Is TX is equal to 0? Why is it printing the wrong one. Get packet RX. So it should run this. Is TX is equal to 0. Why did it report all of those as RX? Wait a minute. What the hell's going on? Upload this code. Yeah, those are saying RX now. Okay. So I'm going to do turn it off. Turn it on. Clear the output. Probably should reset the microcontroller, but there we go. And then hit a button. And then we go Control A, copy. And then go to Notepad, Control V. It still says T. I think I'm not copying properly. Serial readout. Stop the auto scroll. Let's go way up here. There. That should do it. There we go. Okay, all right. Man, I wish this was a little bit more compact. It's just not letting me do that. Reset bondable mode, bondable configuration, blah, blah, blah. Hardware, gap end procedure. That's all the configuration for Bluetooth. Set soft timer. That's the first soft timer set. Connect and the procedure. There's nothing after that. Weird. Set parameters, soft timer, characteristic value. Write, read, write, read. Read, write, set, connection, get RSSI. All right. So here's where it sets the characteristic notification. Ah, here we go. Okay. That's what I wanted to look at real quick before we are done here. So save that. This is good data. We got good data. Beep, boop, bop, bop. So message ID is 5 from the 09 bank. So 95, and then we get 21-1. Why is it 211? That's a different. Client configuration flag is 1. Huh. 9-5. Length of 4. 5 and 6 are a uint 16. Here and here. And then it's little endians, so it's 2101. 2101? Connection handles 2101? But it's still asking for 01's RSSI. Wait, 21 is the... What does that mean? Where is it setting up 1A then? Module 0121. But then when it does 0111, it's a button press. I am confused. I wonder if we see it setting up like a 1A, if it has to do these individually. This value is normally received from the GAT characteristic event. 0121, I mean, maybe we need 3 of these. 0121, 0111, and 011A might all individually need to be set. Maybe that's what's going on. Hold on a minute. So if we have... where are we? Oh, yeah, 011A, 0111. Ha-ha! Yes! That's it. These, it's actually the, I'm good at math, chat, all right? I'm very good at math. I'm very good at math. I'm very good at math. This is the $17.30 signal right here. That's it. That's what we needed. We needed to either respond to or send out these 3. I think we need to respond to these 3. That's it. That's the key. That's what we're going to implement tomorrow. Thursday. Sorry, Thursday. Thursday, we're going to do this. That's it. Right there. Beautiful. How cool is that, though? How cool is that? We would never have known that it was individually setting up the 3 different command IDs that we extracted from raw values to define all of the different stuff that's going on, right? Remember, we identified these, and I thought they would just be generic. You know, I didn't think they were doing this all within the purview of exactly what SI Labs has. What the Scandinavians decided to do was set up 3 events, and they ID'd them this way. And so the other module knows that when a button is pressed, it triggers an event. It also has a couple events for RSSI and an event for battery. None of that was set up. Now we know how. Now we know how. We need to respond to or send out these signals. Well, so there is an incredible amount of proper documentation for everything but what Granite Devices specifically wanted to set up in order to get this module to run as a remote wheel. It's interesting that they're able to do that and charge so much for each individual one. I wish I could do that with something, you know? Just yeah, let's just use this Bluetooth module as a remote wheel, and all we need to do is within the operation of this device, we can just have it send events. It's pretty crazy. I mean, it's all kind of, I'm sure we could find examples that sort of lay out exactly how to set that up, but it's unique. It's a signal that they decided for this thing to send, so we would probably have had no idea on how to implement it specifically, because I don't know who's sending this right now. I think this is from the module to the base station, because this is serial 3. Serial 3, no, this is the base station of the module, because the timer expiring was the module to the base station, and this is received from the base station. So if we responded to these properly, I guess we probably could have gotten the buttons and stuff working. We probably should have responded to these. I mean, they're a 2-0 signal that we don't recognize. 951110001, and then I think we would have just responded, yes, of course we know what's going on. So it might be that one of the values that comes before these makes, you know, triggers these to be sent to us. But we need to respond to those, because we now have identified the 3 different types of data that come back from us being set up. So it's all the way down here with 9.5. Battery. Yeah, and we just generically respond with an all go ahead. Okay. There might still be some things hidden inside of here that we haven't exactly properly implemented, but we have a place to go tomorrow. We got something to look at now. Oh, thank you. I know this is like fairly complicated and it's pretty over the head, over everyone's head, you know. We're deep in the weeds right now because we're this fucking close to finishing reverse engineering this thing, and we had to. I mean, I had to reverse engineer it. It's the only way, because we had at one point when we were working on this thing like years ago, we had somebody who claimed, and you know, you can't question it. If somebody says they work for Granite Devices, I'm liable to trust them, especially if they have a vaguely Scandinavian sounding name. But somebody mentioned that they worked for Granite Devices and that they were going to release an API soon. But again, this is years ago and it never happened. It would be very nice if we had some kind of a serial API where we don't have to fake being a Bluetooth module and we could just say, you know, oh, hey, we are in fact just buttons over serial. And then they just listen to us after that. We send it a packet that has a certain form that gives button presses, even analog values, right? That would be great. but we don't get the luxury of that because Granite Devices said, we're done with the SimuCube. We're just going to make our own closed system. We're just going to close it all off. So they did. And so you buy sort of an all-in-one unit from them, and you can hook it up to whatever wireless wheel you want. But I mean, that's just the nature of the customers for simulator stuff. They're not interested in doing what we're doing. The Open Wheel project was, but again, they kind of deleted the whole page that had all the information like this that we would need. So we're stuck in the weeds looking at SI Labs' API, which is luckily known, but then we need to extract all those unique things from the API that we need to, you know, properly implement in order to get button presses to actually work. So that's what we're going to work on Thursday. If I have time tomorrow, maybe I'll start setting up that program so that we don't need to futz around so much. I'm going to save this. If anybody's interested, if anybody wants to read along, just bug me on Discord, because I'll happily I'll happily share this stuff. It's just not really in much of a shareable state at the moment. But I can share, you know, our logs from today and this stuff if you want. I don't know. Be careful about backseating, because it's sort of like, you know, you flip a coin to see whether or not I'm going to be annoyed by the backseating at that particular point in time. So, all right. I think there's like one or two little things that we need to do, and we're going to work on that on Thursday. I will see you guys then. Take care. Until then, here's the end card with all the information if you're wondering. I haven't posted anything on Twitter in a long while, and I need to. I'll figure something out. I'm still working on designing a computer in CAD and doing all kinds of other stuff like that. But projects will continue, and I'm going to be on a little bit more of a regular schedule. There's been a lot of cancellations and stuff lately just because my, I don't know, life gets crazy sometimes. So anyway, follow me if you want to. I will catch you guys on Thursday. Until then, take care. That's it. That's it for me. Go away. Get out of here. Get out of my freaking... I don't want to see you guys anymore.